上天的说。
சார் மார்னிங் சார். சொல்லுங்க வாங்க சார். இப்போ வீட்டில் தான் சார். வீட்டில் கேட்குதா சார்?
Oh, wait. A very pleasant morning to everyone. It's my pleasure to welcome all the participants, the staff, and the students to the second day of this international conference. We really appreciate the sincerity of our guest speaker, Dr. Anuja Matthew, who has joined this meet very early in spite of the different times. Also welcome the second speaker of the day, Dr. Kavita Rajashekar, who has also joined this meet. Welcome, ma'am. Without further ado, let us proceed to our first talk of the day. A healthy immune system equals to a healthy body. Immunity is conferred upon us due to various factors, one of which is vaccine. We have with us Dr. Anuja Matthew, who is going to share much light on the topic, immunity to COVID vaccines. Participants, please post your questions in the Zoom chat box or in the YouTube live chat. I now invite Dr. R. Uma, Assistant Professor, Department of Biochemistry, to introduce our speaker. Over to you, ma'am.
A very good morning to all. It gives me immense pleasure to introduce today Dr. Anuja Matthew, Associate Professor of Research, Department of Cell and Molecular Biology, University of Rhode Island, United States. She completed her master's in medical microbiology in CMC Wello and a PhD in biomedical sciences in University of Massachusetts Medical School, USA. She has got teaching and mentoring for undergraduate, postgraduate, and postdoctoral fellows for more than 2 decades. Ma'am has served as a member of various committees. To list a few: a member in Institutional Biosafety Committee, Flow Cytometry Committee, Women's Faculty Committee, Life Science Advisory Board, etc. She has published 2 book chapters in Springer and 10 review papers and 35 original articles in well-reputed Sci-Index journals. She has membership in professional bodies, which includes American Association of Immunology, International Society for Virology, and American Society for Tropical Medical and Hygiene. She has been awarded a grant in NIH Immunology Training Grant in the year 1995 to 96, National Research Scholarship Award in 2002 to 2003, and Infectious Disease Committee in the year 2018 to 21. Add on to her credentials, she was a reviewer in many prestigious journals. To list a few, which includes Nature, Nature Microbiology, Nature Virology, Nature Vaccines, and Journal of Immunology, Journal of Virology, and Virology Research. I welcome you, ma'am, to deliver the plenary lecture in the topic Immunity to COVID Vaccine. And I welcome you once again, ma'am. Thank you.
Thank you very much. Can everybody hear me?
Yes, ma'am.
And maybe I can start sharing my screen, right? That's what, oh, it says host disable participant screen sharing. So somebody has to give me permission to share my screen. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Okay.
Technical team, can you please allow ma'am to share the screen?
I think, okay. Can
Ma'am,
you
your
see my
screen is
slide?
visible, ma'am.
Okay, and you can see my slides?
Yes, ma'am.
Okay. So please just stop me if you can't hear me or if I get stuck in
Yeah,
any
sure, ma'am.
manner.
Sure, ma'am.
So thank you very much to all the organizers for inviting me to give this talk. My name is Anuja Matthew, and I'm a cellular immunologist. I've spent 2 decades studying human immune responses to flavivirus infections, and particularly dengue virus and Zika virus. Many of you may have heard about it because these viruses infect people in southern India, South America, etc. But today I'm going to spend the next half an hour to 40 minutes talking about immunity to coronaviruses. I hope you can see the slide properly, but so in December 2019, the WHO alerted us, that there was a string of respiratory cases in Wuhan, China. This is late in December of 2019. And within 3 weeks, gene sequencing of a new virus known as nCoV 2019 was established and shared globally. This virus was later identified to be a coronavirus. The coronavirus belongs to a family of viruses, and this particular virus belongs to beta coronaviruses. These viruses express several proteins on their surface, including the envelope protein that interacts with the membrane protein to form the viral envelope, and very importantly, the S protein or the spike protein. And this spike protein that's present on the surface of the virus is critical for binding of host cell receptors, and they facilitate entry into the host cell. So when you get infected with a virus, quite often you may not have very significant symptoms. But if you develop symptoms, the very common symptoms are fever, dry cough, and fatigue. And uncommon symptoms include symptoms that are very similar to many respiratory infections. So headache, congestion, sore throat. But something that's a little bit unique to COVID-19 symptoms are quite often people lose the sense of smell. And in severe disease, there may be high fever, coughing up blood, decreased white blood cells, kidney failure, and eventually, in some cases, leads to death. So it's now understood after 1.5 to 2 years of having this infection, there are 2 phases of infection. So during acute infection, which lasts about a couple of weeks, you have virus that can be isolated from the respiratory tract. And during this acute phase, you have many of the symptoms that I just described. But in people who get sick and recover, there are long-term symptoms or post-acute clinical features of COVID-19, and they vary very much in individuals. So these can include fatigue, decline in quality of life, which lasts several weeks and months, anxiety, depression, cough, persistent oxygen requirement, palpitations, chest pain, thromboembolism, etc. So these can last close to 6 months to a year, and there's active research to find out why people are developing these post-acute symptoms and how long they last and what treatments could be available to relieve people with long-term COVID symptoms. So I just want to go over certain statistics before I get into the immunology of coronaviruses or how humans respond immunologically to the infection. So if you just look at the tracking of the global outbreak, if you look at the total number of cases and the number of deaths to date, there have been close to 4.5 million to 5 million deaths that have been reported as a result of coronavirus infections, and over 240 million cases of coronavirus. And this table pretty much shows the top 10 countries in terms of the total number of cases and total number of deaths. So in the United States, there have been over 44 million cases reported to date, and this is updated as of yesterday. and over 720, I mean, close to 725,000 deaths as a result of COVID-19 infections. Brazil and India have reported the most number of cases next after the United States, and the most number of deaths as well. So while we've had a lot of infections and a lot of deaths, in a matter of 2 years or less than 2 years, 12 to 18 months, we have several vaccines that are available. And many countries have over 50% of their population that have been vaccinated to date. So vaccine development typically is a very lengthy and expensive process. So traditionally, it takes multiple years to develop a vaccine against many agents. So for example, for poliovirus on the right, from the time poliovirus was recognized as a pathogen to the development of a vaccine, it took approximately 60 years. In contrast, Ebola virus, a virus that causes disease and has high fatality, there was also a significant number of deaths reported for Ebola virus, and it took approximately, I think, 15 or 16 years. And in stark contrast to SARS-CoV-2, which is the pathogen we're talking about today, in 12 to 18 months, there are several vaccines that have been administered to people already, and there are many that are also in clinical trials currently. So what's the difference? So traditionally, for vaccine development, you make a decision about a candidate vaccine. Once you make the decision, it's a go or no go decision. Then you start clinical trials. The first clinical trial in humans would be a safety trial. Once you look at the results of the safety trial, then you go to an efficacy trial, which is a phase 2 trial. Then you go to evaluation of safety and immunogenicity and efficacy, or a phase 3 trial. All of these happen, one after the other. And then at the same time, once you are getting the results of these clinical trials, you're trying to first start out with small scale clinical trial material to do the phase 1 trial. If the phase 1 trial looks good, then the manufacturing scale up is larger, and you have a validation process, commercial scale, and finally you have large scale manufacturing and licensure. So this usually takes typically around 10 years for a vaccine to be licensed. In contrast, for coronavirus 2, what happened is multiple things happened in parallel. And this took a lot of effort from government and private industry to make very large commitments of funding, because they didn't know at the time whether any of these vaccines that they were going to be testing would be safe and efficacious. But both government and industry in partnership were willing to invest large millions of dollars and realize that if any of these vaccines were not safe, it would be a loss of millions of dollars. But they took that risk. And because of that, within 12 to 18 months, we have several vaccines that have been administered around the world to so many people. So I'm just going to talk about then approximately 3.5 billion people have been vaccinated to date. On the right shows a number of countries or where people have been either partially vaccinated or fully vaccinated. So in dark green represents the number of people that have been fully vaccinated. So in a country like USA and Canada, or in North America, over 65% of people have been already vaccinated. And many of these people have already received their 2 doses of vaccine that's required for a good, efficacious vaccine. In Asia and the Pacific, maybe about 50% of people have received at least 1 dose of a coronavirus vaccine. In contrast, in Africa, less than 10% of people have been vaccinated with at least 1 dose of vaccine. So there's quite a bit of disparity between the Americas, Asia, and Africa, and the Middle East in terms of how many people in each country has been vaccinated to date. And the hope is, if there are enough vaccines available and licensures approved, that most of the people on the planet who are willing to take a vaccine would be able to get a vaccine in the next few months. So as I mentioned, there are a number of vaccines. One of the vaccines that's been administered in India and actually over 180 countries in the world is the AstraZeneca vaccine. And the AstraZeneca vaccine was developed originally at the University of Oxford. So this vaccine is also known as Covishield in India. There are other vaccines that have been administered to a large extent in the United States. These are generic vaccines, including the Pfizer-BioNTech vaccine and Moderna vaccine. I'm not going to go into too many details, but also to mention that there's a Bharat Biotech vaccine, which is an inactivated COVID vaccine, which has been administered in 7 to 8 countries, and that list is growing as licensure or acceptance of the vaccine in different countries takes place. So there are a number of vaccines that are being administered, and there are also vaccines in development, for example, here, that have been identified and only been tested in 1 or 2 countries around the world. But we're not going to talk much about these vaccines today. I'm going to focus mainly on the Oxford AstraZeneca vaccine and the 2 mRNA vaccines, and talk a little bit about immune responses to these vaccines and immune responses to natural infection. Okay, so I want to take a little bit of time to talk about the different kinds of vaccines and what they're attempting to do. So one major category or type of vaccines that have been administered are known as viral vector vaccines. So in this type of vaccine, so an example of that would be the AstraZeneca or the Oxford vaccine or the Covishield vaccine. Here, they use an unrelated harmless virus. In this case, it's an adenovirus. And this virus is modified to deliver the antigen, and which is a SARS-CoV-2 spike protein, or the genetic material that's present on the surface of the virus, which is the spike protein. The delivery virus is known as the viral vector, and that's expressing the SARS coronavirus 2. So when you get vaccinated with this vaccine, our cells use the genetic material to make the specific SARS-CoV-2 protein, which is the spike protein, and which is recognized by the immune system to trigger an immune response. And the immune system builds immune memory, so your body can fight SARS-CoV-2 in the future. So some of the considerations of the viral vector vaccine are they generate a very strong immune response. However, there's some practical considerations because they need to be stored at a specific low temperature. As an example, as I mentioned, was the AstraZeneca vaccine. And other vaccine that uses a viral vector vaccine is an Ebola vaccine. And approved elsewhere for the world are either CanSino or the Janssen or the Johnson & Johnson vaccine. So another different kind of vaccine, or a nucleic acid vaccine, has also been widely used across many countries. Here, this vaccine contains a segment of the SARS-CoV-2 genetic material that codes for a specific protein. Again, here it is the S protein or the spike protein. Genetic vaccines could be either DNA or RNA, and the 2 most widely used vaccines, the Pfizer-BioNTech vaccine and the Moderna vaccine, encode for mRNA. So our cells use the genetic material to make the SARS-CoV-2 S protein, and this S protein then triggers an immune response. Again, it's the considerations for this kind of vaccine, it's low cost and it's fast to develop. So that's a significant advantage. However, again, it needs to be stored at very specific low temperature. So that's a disadvantage in countries where that's a challenge. As I mentioned, the Pfizer and the Moderna vaccines are examples of nucleic acid vaccines, and Inovio Pharmaceuticals is developing another genetic-based vaccine for SARS-CoV-2. And just the final vaccine that I'm going to talk about today are the inactivated vaccines for SARS-CoV-2. This is slightly different because it contains killed or inactivated SARS-CoV-2. So the previous 2 vaccines only use a specific part of the whole virus known as the spike protein. However, in inactivated vaccines, what they have is the entire virus. So in addition to the spike protein, you have all the other proteins, and all of these proteins can serve as antigens to trigger the immune system. So in a sense, the killed SARS-CoV-2 virus can generate a much broader immune response to multiple different proteins that are expressed on the whole virus. This response builds immune memory so your body can fight SARS-CoV-2 in the future. Examples of other inactivated vaccines include the influenza vaccine. What's used elsewhere in the world for COVID-19 includes the Bharat Biotech vaccine. And there are several examples of inactivated vaccines for SARS-CoV-2, including Sinovac and Sinopharm. So these are just in a broad sense, the different kinds of vaccines that have been developed and administered, run through several trials. Results have been published and are now, actively being used in people. So what happens to your body when you get a vaccine? So this is just looking at when you administer a whole virus. So this is looking at a coronavirus. And as I mentioned before, the coronavirus has the spike protein on the surface and M protein on the surface, and it encodes for RNA. So this virus, so this is just talking a natural viral infection, when it enters your cell, it binds a specific receptor. The receptor for SARS-CoV-2 is the ACE2 receptor. The virus enters the cell, fuses with the vesicle, RNA is released, RNA is translated into proteins, progenivirus is generated, and then you have new virus that's released from the infected cell. So this virus can be ingested by certain kinds of cells known as antigen-presenting cells. Examples of antigen-presenting cells could be monocytes and macrophages that travel across our body. So the virus is ingested by the antigen-presenting cells. It's broken up or chewed up into small pieces, and these small pieces of propeptides are presented on major histocompatibility complexes that express these small peptides. So this antigen-presenting cell is telling the other cells in the body, the adaptive immune cells in the body, I'm expressing a foreign alien protein, come and identify me and get activated. So there are many kinds of cells that get activated. One type of cell is known as a T cell or a T helper cell. This T helper cell can recognize these small viral peptides presented on these specific molecules. Once they get activated, the T helper cells can activate another kind of cell known as the B cell. And the B cell is really a factory once it gets activated for producing antibodies. And antibodies are a key mediator of protection against infection. So the T helper cell can also activate another kind of cell known as a cytotoxic cell. And the cytotoxic cell is another component of the adaptive immune response. And the cytotoxic cell can destroy an infected cell and kill it. So the T cell and the B cell are very important components of immune memory. And this is what you want to have. If you have a good vaccine, you want to generate very good memory B cells and memory T cells, because when you're exposed down the road, you want these T cells to get activated and kill any viral infection. And you want the B cells to activate and secrete lots of antibodies. And you want the antibodies to eliminate the virus infection. So long-lived memory B and T cells is a hallmark or a goal of all vaccines. So every vaccine manufacturer or every vaccine company is looking to generate very strong immune responses by generating good antibodies as well as T cells. Okay, so as I mentioned, for all of the coronaviruses, to date, a major focus has been on the spike protein or on the surface of the cell. And we know that the spike protein is a strong target of antibodies. The spike protein has two subunits, the S1 subunit and an S2 subunit, and it also have a receptor binding domain. So a lot of work from previous studies, the reason that we've had so much success in getting vaccines into people within 12 to 18 months is because in the previous 10 years, a lot of effort has gone to understanding, say, mRNA vaccines, why they were failing. People have worked very extensively to try to modify mRNA vaccines to make them more immunogenic. A lot of researchers have spent a lot of time studying other viruses, and these lessons learned from other viruses, including a virus known as a respiratory syncytial virus, were critical to make important modifications to current coronavirus vaccines. As an example, one lesson that was learned from the RSV, or the respiratory syncytial virus, was when it's present in its pre-fusion form. So this is showing you on the right is the pre-fusion form. In orange and in red are certain antigenic sites that are seen that are very strong targets of antibodies. And it was recognized earlier on that keeping the F protein of RSV in the pre-fusion form was much more immunogenic compared to what happens post-fusion. So when it's post-fusion, this protein elongates and you no longer see the orange or the red. Because you no longer see the orange or the red, there are less targets of antibodies. So it was understood early on from the experience from RSV that keeping this protein in the pre-fusion form was actually quite an advantage. Because of the understanding for the mRNA vaccines and for some other vaccines, they recognize that the S protein might also need to be in its pre-fusion state because it had similar proteins, similar functions compared to the RSV-F protein. So particularly for the mRNA vaccines, two prolines were introduced into the structure to stabilize the S protein so that it will continue to stay in its pre-fusion form and not become this lengthy, long post-fusion trimer. Because it was understood that if you keep it stabilized in the pre-fusion form, you will have many more targets of antibodies. And if you have many more targets of antibodies, you're generating a much more immunogenic vaccine. So this is one of the very early advances that were made that was a significant advantage in making a very immunogenic vaccine. Okay, so as an example, again, the three mRNA vaccines, which are the BioNTech, the Moderna, and the CureVac from Germany, all included these stabilizing mutations, that is introducing the true prolines to keep the S protein in its pre-fusion state, and also the Novavax vaccine, which is a subunit vaccine, which is still in trials. And and the Johnson & Johnson vaccine. Several of the other vaccines, including the AstraZeneca vaccine, did not include modifying the S protein to keep it in its pre-fusion state. This is also the table is also giving us an idea of the different kinds of doses that we used for the vaccine. So as an example, again, the BioNTech Pfizer vaccine used 30 micrograms of RNA, versus the Moderna vaccine actually used 100 micrograms of RNA. And the CureVac or the mRNA from Germany used only 12 micrograms of RNA. So this difference in dose actually has had an impact in how strong immune responses were generated to each of these vaccines. There are many studies that show very strong immune responses post-vaccination with either the Moderna or the BioNTech vaccine. And it's thought that the CureVac vaccine did not generate as strong immune responses because a lower dose of RNA was used as the optimal dose. And some of these decisions were made because they had done small trials and recognized what doses might be optimal. And some of it was also a little bit of a guess. But for both the Pfizer and the Moderna vaccines, very strong immune responses have been detected post-vaccination. Okay. So I just want to show you some preliminary, some data that's been published showing the efficacy of these vaccines. So this is a study that was published in the Lancet in 2021, looking at the safety and efficacy of the AstraZeneca COVID vaccine, or Covishield as you all know it in India. This is an interim analysis of 4 randomized controlled trials in Brazil, South Africa, and in the UK. Over 11,000 participants in this trial, about 4,000 in Brazil. And here they were given either 2 standard doses of the AstraZeneca vaccine or the control vaccine, which is a meningococcal vaccine. And I'm not going to go into the details other than to say that the cumulative incidence of symptomatic COVID after 2 doses or after a standard dose was much lower in the group that was treated with the COVID vaccine compared to the control vaccine. So these 2 standard doses gave us about a 62% efficacy in this trial, which is about what the AstraZeneca trials have reported. So how really do vaccines work? So whether you have a natural infection or a vaccine activates various immune cells, and we've gone over that, but I'm going to go over it again because I'm trying to drive home the point. How do vaccines generate strong immunity? So a vaccine, in addition to a virus, activates various immune cells. So it activates an antigen presenting cell. So when you get immunized with the vaccine, you generally get it into your muscles. So some of the muscle cells and antigen presenting cells that are present in the local lymph node get activated. These antigen presenting cells present part of the vaccine. In this case, it would include, if it's the AstraZeneca vaccine, would include both components of the vector, which is the adenovirus, as well as the S protein. All of these things are presented as peptides. They activate T cells, and one component is the helper T cell. The T cell then activates B cells, and I mentioned before, B cells can become activated plasma cells and secrete antibodies, and measurement of antibodies is a very strong indicator of an immune response being generated against the protein. So the hope is when you immunize with the S protein, you get lots of antibodies against the S protein of SARS-CoV-2. And I just also want to mention that the S protein has numerous sites. So you're getting antibodies of different specificities to different parts of the S protein. And as the second arm of the immune response is the T cell arm of the immune response. And in this situation, you activate helper T cells and as well as killer T cells. And these killer T cells recognize antigen presenting cells and can actually eliminate them from the system. So in the situation where antibodies do not clear viral infection, or circulating antibodies do not clear viral infection, the second arm of the immune system, which is the T cell arm of the immune system, is required to come and clear out virally infected cells. Okay, I want to take a little bit of time to talk about antibodies because there's maybe a little bit of poor understanding of the different kinds of antibodies that are generated to any viral infection or any pathogen or any vaccine. The example that we're talking about today is SARS-CoV-2, but it could be to any vaccine. So it could be to tetanus, it could be to any vaccine that you get, an Ebola vaccine that you get, or a dengue vaccine that you get. So as we talked about, B cells secrete antibodies. The antibodies recognize different portions of the proteins. In this case, it's the S protein. But in addition to recognizing the S protein, antibodies also have very different functions. So the antibodies recognize and see the S protein, but they can mediate effector function through many different ways. One common way is known as neutralization. So neutralization, basically a neutralizing antibody can block the virus. And when it blocks the virus, it can prevent the virus from infecting a cell. And when it prevents the virus from infecting a cell, then you don't have much, then you're eliminating the virus from getting into a cell. So you're blocking and getting the virus out of the system. So neutralization is a very strong indicator of generating good antibodies that can eliminate virus from the circulation. There are many other ways of also eliminating virus. One of them could be opsonizing and phagocytizing of microbes. This depends on certain subsets of cells known as monocytes or macrophages to opsonize and phagocytize the virus, or that when you're subsequently exposed to an infection. There's another mechanism. So these antibodies have different specificities. So neutralization is one, opsonization is one. Antibodies can also eliminate cells by activating another subset of cells known as natural killer cells. And these natural killer cells via a function known as antibody-dependent cellular cytotoxicity can also eliminate virus and infected cells. There's also activation of the complement system, and the complement system that are opsonized with complement fragments can phagocytize microbes. So I just wanted to mention that when you look at antibody titers, so many people ask for antibody titers, but the definition of, antibody titers is quite challenging because antibodies have very different functions. So if you just look at geometric mean titers of antibodies, that's just looking at binding of antibodies to a specific protein. And that's not really as meaningful because it doesn't tell you what function those antibodies are performing. If you also do an additional assay, like a neutralization assay or an opsonization assay, that would be significant knowledge. So just looking at titers is not really that informative. Okay. So this is data from a Nature Medicine article, again, looking at a phase 1-2 trial, where they looked at the AstraZeneca COVID vaccine, looking at antibody titers in a 2-dose regimen to the spike protein. And I'm not going to go into too much detail other than to make the point that after vaccination, so this is looking at days after vaccination, and looking in groups that received either in the orange lines, looking at people who received 2 standard doses of the AstraZeneca vaccine. In the blue lines are the controls, those who received the meningococcal vaccine, and either looking at standard dose at day 56 or day 28. So the main point really is, compared to the blue lines, which are the control, all of the vaccine administration over 2 doses generated strong antibody titers. So here they're looking just at binding of antibodies to the spike protein. And these are geometric mean titers, and they look strong for binding to the spike protein. They also looked at virus neutralization, and this is looking at a specific function of the antibodies. And after vaccination with a 2-dose regimen, post-vaccination, especially after 2 doses, the neutralization titers in humans increases after administration of 2 doses of either the standard dose or the standard at day 28 and day 56. So this is very good indication that the AstraZeneca vaccine generates strong antibodies titers a month to 2 months after vaccination. So in this study, I only took 2 figures out of this whole paper. If you want to read more, please look at this paper at Nature Medicine. They also measured many other functions of antibodies. As I just gone through in 2 slides before, there are many functions, including monocyte phagocytosis. So this is telling you that these antibodies can eliminate the pathogen when the monocytes of the macrophages phagocytize in the presence of the antibody. So they looked at monocyte phagocytosis, neutrophil phagocytosis, complement deposition, and activation of NK cells and elimination by cell-mediated cytotoxicity. And in all cases, the AstraZeneca vaccine generated fairly robust titers to measuring these specific functions of antibodies. So the point is that this study was a comprehensive study that not only looked at the binding of the antibodies, but they also looked at many different functions of the antibodies, including neutralization and many of these listed below. All right, this is one more study that was done in India. This is looking at antibody responses, comparing Covishield versus Covaxin, looking in people who are either less than 60 or people who were older than 60, people who either had comorbidities or did not have any comorbidities, people who had prior COVID infection or people who had no COVID infection, looking at antibody titers. Here, this is just looking to see whether they had antibody titers to the spike antigen. And the conclusions from the study, again, if you want to read the whole article, please go take a look at the article below published in Vaccine. But the conclusion of the study is both vaccines, that's both Covishield and Covaxin, induced anti-spike antigen antibodies in 95% of the recipients. In people who already had COVID, the responses were higher, and that makes complete sense because they already had immune memory or immune T and B cells that were generated. Once they received the vaccine, they were then, these memory B and T cells were activated and secreted more antibodies, and you had higher titers in those who had prior history of COVID infection. The other, I guess, point to make was Covishield in general had higher antibody titers compared to Covaxin. And this is looking at probably 3 to 4 weeks after they had received vaccination. So just to conclude with this, so many vaccines have shown through several published studies that strong antibody titers are elicited in people who've received 1 or 2 doses of either one of the of these vaccines. All right. So antibodies, for the most part, do good things, but can antibodies do bad things? Is there any danger or potential damage if you generate suboptimal responses to antibody responses in due to SARS-CoV-2 infection? So I just want to spend a couple of slides talking about a phenomenon known as antibody-dependent enhancement and the possible or potential danger of generating antibodies that are not good. So as I mentioned, you generate antibodies, and the main type of antibody is a neutralizing antibody, which if you generate in high enough titers, that's a good thing because these neutralizing antibodies can block the virus by binding to the spike protein. And because they bind to the spike protein can no longer bind to the receptor, which is ACE2 on the host cell. So it prevents the virus from entering into the cell. So this then is how neutralizing antibodies work. But if you generate antibodies that are not neutralizing, these antibodies basically could bind to some portions of the spike protein, but they cannot neutralize it. These antibodies bind to a different kind of receptor on cells known as monocytes and macrophages. And instead of actually preventing infection, what happens is this antibody acts as a bridge and enhances infection and allows the virus to get into the cell. So this process is known as, or phenomenon is known as antibody-dependent enhancement, and has been talked about considerably as potential danger of generating bad immune responses to SARS-CoV-2. So there have been many in vitro experiments that show that certain antibodies to SARS-CoV-2 can mediate this phenomenon known as ADE. They've been done in vitro cultures predominantly, or they've been performed in vivo in animal experiments. So they may have been done in murine, in mice or in ferrets or in some other animal model. But to date, there's been no evidence, clear evidence that people who develop antibodies, and if antibodies wane over time, there's a potential danger of getting more sick from having, say, a vaccination or a natural infection when you subsequently have an infection. So I think there was a lot of concern and a lot of reviews published on the potential danger of antibody-dependent enhancement, but I have seen no clear evidence in the literature to suggest that this happens following natural infection. And in theory, months after you have a vaccine, if antibody titers drop, they may or may not. If they drop and you then subsequently get infected with either the original strain or a variant strain, there's still a theoretical possibility, but it hasn't happened as of yet. Okay, so I just want to talk a little bit about the durability of the response. So when you have vaccination, I've shown you at least 3 published studies to say that you generate very strong antibody responses. So if you either get infected naturally with SARS-CoV-2, what happens is, few days after you have an infection, first you have symptoms. You have a fever, dry cough, the virus replicates in your body, the virus is presented on antigen-presenting cells, it activates the immune system, B cells get activated and secrete antibodies. So slowly, maybe a week to 10 days after you've had infection, you start seeing an elevation of rise of SARS-CoV-2 antibodies. And we've already talked about how these antibodies have different specificities and different function. So you have a rise in antibody titers. They peak and then they slowly decline. So this is an example of one individual that in 10 to 14 days, you have a peak of responses, and then you have a stable immune antibody titer for several months and up to 1 year. This is just a theoretical example. So here's another individual. So another person could be infected with the same virus at the same time. This person may also initially start with a good immune response, and then the immune response declines. And within 6 months, this person, in contrast to the first person, has a much lower immune response. And this is below this dotted line, which is the threshold of detection of antibodies. And this person, basically, if this person got infected at 6 months, will have no antibodies available to protect themselves. However, if the first person, as an example, does get this infection, they have enough antibodies that might be able to prevent the infection. So people are very heterogeneous in terms of how they respond to an infection or vaccination, and that depends on their past history, what kinds of viruses they've been exposed to, and how well they've processed this particular antigen or vaccination. And vaccination and natural infection are pretty much the same in terms of trying to generate an immune response. When you have natural infection or an inactivated vaccine that has the whole virus, you're generating a whole host of antibodies. In contrast, when you have, say, either the mRNA vaccines that only express the spike protein, or the AstraZeneca vaccine that also only expresses the spike protein, the antibodies that you are generating are only towards that protein. So it's only to the spike protein. Here's an example then of different people who start out with a response and then that rapidly declines, someone who did not generate a response at all. So the point of this slide is just to show you that people generate all kinds of responses, and the longevity of the responses also differs quite differently in every individual. So you don't know, so many of you in South India may all have different immune responses, even if you've all received the vaccine. So what happens 6 months to 1 year after vaccination or infection? So mild or asymptomatic infection may be more representative of a low dose vaccine where you have a very low immune response generated. A symptomatic natural infection or a high dose vaccine like the Moderna vaccine, you might have a much stronger antibody response that lasts longer. So these are all the considerations that need to be taken into account when you think about what vaccine you've got, how long your responses last, and when you should be thinking about a booster vaccine if you are considering one. So here's real data from a study in Qatar showing longevity of immune responses. So the key really is to know, if all of the data to date showed that within 1 or 2 months of having vaccination, most of the vaccines generate a very good titer of antibodies. But the question really is, how long do those antibodies last and how effective are they? And is there another component of the immune response that's coming into play? So in the top panel, it's showing you months after the second dose. So they go 1 to about 7 months after the second dose of SARS-CoV-2 infection. And this is looking at the Pfizer-BioNTech mRNA vaccine. So as I mentioned, you have very high titers in the beginning that last, and then as expected over several months. So after 3 to 4 months, or even up to 6 or 7 months, these antibodies titers quite significantly drop off. But then the question is, if you get exposed, say at month 6 or month 7 to SARS-CoV-2, now do these antibodies have any function at all? So in the case below, or in the panel below, this is showing you effectiveness against any severe, critical, or fatal COVID disease. So in looking at the same individuals, even though their titers dropped over several months, these people were still had an effective response against developing severe or critical fatal COVID disease. So they may have got infected, with SARS-CoV-2, but the infection was quite mild. So this is still, in my opinion, a success story, because if you can prevent having a severe infection and now have either a mild or even moderate infection and not be hospitalized, that is a significant advantage to you. Now, we don't know yet what happens if it's 1 year post-vaccination or 2 years post-vaccination, whether these titers are going to drop even further after receiving the vaccine. It's likely to happen, but we don't know that yet. And people are very actively looking to see how long antibodies last after vaccination with each of these formulations. So do the mRNA vaccines in general have a higher response compared to, say, the Covishield or Covaxin vaccines? So to date is thought to be the case, but it still has to be shown how long and durable these responses are. So in the last few slides, I just wanted to talk about the other component of the immune response, which is the T cell arm of the immune system. So here, as I mentioned, there are many types of cells, including T cells. And one type of cell is known as a CD4 T cell, and the other type of cell is known as a CD8 T cell. The CD4 T cells are typically T helper cells, and the CD8 T cells can expand and become cytotoxic cells, and they can actually clear infection. So this is in the other arm of the adaptive immune response, and also a very important component to eliminate virally infected cells. So we talked about many studies with B cell priming and showing the antibodies that activated B cells secrete. And we looked at a number of antibodies and a number of studies showing that many of the vaccines generate good antibodies. So do these vaccines also generate good T cells? And having good memory T cells is important for an efficacious vaccine. So I'm just going to show you one study, again, looking at post treatment with the Charox vaccine, which is the AstraZeneca vaccine, in a phase 1/2 clinical trial. And this is also a study published in Nature Medicine, where they looked at CD4 T cells and CD8 T cells, just to make the point that CD4 T cells and CD8 T cells were generated to the spike protein of SARS-CoV-2. These T cells performed functions like secreting different cytokines, the different cytokines that they looked at. I'm going to mention a few: interferon gamma, IL-2, and IL-5. These are typical cytokines that people look at when they're trying to assess whether a good T cell immune response has been generated. And this is showing the frequency of CD4 cells and CD8 T cells that secrete these specific cytokines. In addition, they looked at a cytolytic factor known as CD107A and showed that after immunization with the Charox vaccine, you also have cytotoxic T cells that can degranulate and express CD107A. So both T cells and antibodies are generated following vaccination. Just trying, okay. So I just wanted to leave you with a couple of points. I think there's some echo, but I think it's okay now. So I just wanted to leave you with a couple of points. So there's one point being that there's only finite space in our bodies and in our immune system. So we have a number of cells that are T or B cells. Once we get exposed to a pathogen, there's a big expansion of specific cells. So for example, in yellow are expansion of memory cells to other pathogens. So, we have all had exposure to influenza, RSV. Many of us have been vaccinated to many pathogens. So we have memory responses to other pathogens. When you have an infection, you're generating responses to that specific pathogen. So in blue, for example, are responses to the S protein, which is the spike protein. In red, another part of the SARS-CoV-2, which is the nucleocapsid protein. And this is during an acute infection or you're early after vaccination. And late after vaccination, these numbers decline and they come back to a steady state. But having these memory T and B cells around are very key in the long term, because when you have an infection, these cells get activated at a much quicker rate. They secrete antibodies and they secrete cytokines and are clearly able to eliminate cells. So having a good memory T and B cell response is very critical for an efficacious vaccine. So I wanted to end with 2 or 3 thoughts. How is vaccine-induced immunity holding up? So immunological studies have documented a steady decline of antibody levels among vaccinated individuals. So it is a concern. But antibody levels are circulating antibody levels. If we have cellular immune responses that are longer lasting, that is memory B and T cells, that's a good sign. We still don't know how long these memory T and B cells last after vaccination. And one way to boost it is to get a booster shot. So basically, you get a booster shot with an attenuated version or a smaller dose of the same vaccine, and that will trigger and activate many more memory B and T cells and more antibodies. So there's consideration for people who are highly susceptible in the United States to start getting booster shots, and many people have already received booster shots to COVID vaccines. Should immune memory give you durable protection against severe disease? Yes, it should give you a durable protection, but these molecules are on the decline. So the longer out you are from natural infection or vaccination, it could be worse. And you might be more susceptible to get severe disease. One way, again, to avoid that is if you have access to booster vaccines. And lastly, if you're not vaccinated and you're not getting really sick, is there other benefits? Yes, reducing rates of infection should help break the cycle of viral transmission, which will ultimately result in fewer cases of severe COVID-19 and death. So I think I'd like to end there. I think I've taken a good portion of time, and I might have run out of time as well, but I would like to thank really all the organizers for this opportunity. I hope I didn't speak too fast, and I hope you have some idea of immune responses to coronaviruses and how generating good immune responses will elicit strong and efficacious vaccines. So thank you again very much for the opportunity. And if there are any questions, I'm happy to take them.
Now is the time for queries. There are a few questions posted in the chat box. Shall I read it out, ma'am?
Sure, yeah. I don't think I can hear you. Maybe it's stopped.
Just a minute, ma'am.
Oh, sure, sure.
Here's a question from Dr. Smriti. She's asking about, is there any study for booster doses for COVID vaccine, like antibody titer decline?
Yeah, so there are now several published studies that show that when you get a booster vaccine, the titer of antibodies rises dramatically, so which is a very good thing. So, and there's also some recent studies from Israel showing that when you get the booster dose, really, you are highly protected from severe infection. So they had the case where in Israel, most of the people got immunized very early. And after several months, because of the circulation of the Delta virus, they had started seeing breakthrough infections in people who were already vaccinated. They then went ahead and immunized, gave a number of people booster doses. And in those people who got booster doses, they were able to show very strong antibody and memory T cell responses. And those people who got the booster dose were actually protected compared to those who did not get the booster dose. So, and yet again, very strong evidence to suggest that immunity is playing a key role in preventing these breakthrough infections.
Here's another question from Parimala Saravanan. Symptoms of cold found to be severe after vaccination often found to be susceptible to common and the mediated complaints. For example, like ear block, ear feverish, etc. And her question is about whether it is the response of the infection or because of vaccination itself. Also observed frequent development of this after vaccination.
So the way I understand the question, I hope I understood it correctly. She's asking whether symptoms, can you get symptoms after vaccination? I think it's quite common to get symptoms after vaccination, particularly I think with the mRNA vaccines and the ones that have the higher dose. So, I mean, vaccination in a sense, even though there's no infectious component to the vaccine is trying to mimic natural infection. So the fact that you're having symptoms is actually a good thing. So when we got our vaccination, really, having muscle ache or muscle pain or body ache it's considered a good thing. That means the virus or the vaccine was able to get in to your antigen presenting cells and was processed. And the body is recognizing something as foreign and it's generating an immune response. So it's a very good thing, really.
Yeah, Dr. Anuj, I have a doubt.
Yes.
See, usually vaccine production, as far my understanding goes, it goes to some 3-4 years of general for any infection.
Yeah.
But during this COVID, due to the necessity, it was made less than a year.
Yeah.
Is that really possible? I mean,
Well,
will that
so
be as effective as the one which has undergone the complete procedure of all phases of the clinical trials? As effective as that?
No, I think most people who are very nervous about getting vaccination were quite concerned. And that's exactly because of your point that how did we rush and generate in developing these vaccines? So I guess my point would be that this comes from really 10 years of research that have been done on other related coronaviruses and also developing, say, for example, the mRNA technology and many trials that have been done with adenoviruses to try and optimize the immune response. So it's not to say that this just got rushed in 12 to 18 months. It was depending, many companies have been working 10 years on developing vaccines with the similar vector profile. So basically what the difference is, they took out whatever they were studying before and put in SARS-CoV-2, the S protein. So it's not to say that there is no side effect or no challenges with these vaccines. There are people who have had significant reaction to the vaccine. My point is, I think you have to weigh what the risk-benefit ratio is. If now 3.5 billion people have received the vaccine, and in this country, there's what's called reporting adverse events after vaccination. As of maybe a month or so ago, maybe there are a few thousand people who have reported adverse events. Those adverse events can be quite significant. So some people have had very strong reactions to the vaccine, but that's like a few hundred or a few thousand cases. But the benefit is, if 3 billion people have had an advantage, you're always weighing the risk-benefit ratio, and the benefits, in my opinion, outweigh the risks. But it's not to say there are no risks. It's not an easy question to answer.
Yeah, thank you, Dr. Anuja. Just two quick observations I would like to make in this. So we have certain countries, say especially UK and 1 or 2 countries in Europe, who are not very comfortable with the Indian vaccines. We can understand that from the people who travel abroad. They say that we don't accept your certificate of Covishield or whatever that is. So why should a country ban or be skeptical about the vaccine from, say, especially from our own country, say India? That's first question. If it is not a technical issue, then what could be any other possible reason for that country to ban? Say UK was so specific initially. After the Prime Minister had some discussions, they relaxed the norms, etc. First observation. Second observation is, so what I understand from your answer is, statistics plays a very crucial role in the success of a vaccine. So unless the benefits are strongly supported by the statistics, so I think people will still have apprehensions. Yeah. Thank you.
No, yeah, no, I think I agree. I'm not, so clear about which countries are accepting, vaccines or not. Some of the challenge I think is also political. For example, I shouldn't, if one country is producing their own vaccine, obviously they would, they would want to promote their own vaccines. I think there's been a considerable transparency in terms of sharing of ideas and resources and sequence information. That's another reason why we have moved so quickly, I think, towards getting vaccines out. I don't know, I mean, I'm not the person to I think address what the political situation is or why, but I have to say that if there's published phase 3 data showing the efficacy of the vaccine and showing clear advantages of the vaccine, then I think then it's like getting approvals also is is also a process. So in many, I mean, as far as I understand, one of the reasons why it's been challenging to have the vaccines administered in Africa is maybe getting the approvals has not been that easy. And there's quite a bit of push to have everybody receive a vaccine. It's also money is available to pay for these vaccines. Who's paying for it, I think, is also consideration. That's way beyond the scope, I guess, of this talk.
Yeah, thank you.
Ma'am, I have a question.
Sure.
Ma'am, in UK, last year they started vaccinating very early when compared to India. And they've been advised to go for AstraZeneca. But in the recent few months, they stopped giving AstraZeneca and they're recommending only the Pfizer and the mRNA vaccines. What may be the reason? Because we are following AstraZeneca has been used as a provision in our country. I don't know what may be the reason now.
So as far as I know, the Pfizer and the Moderna vaccines were originally administered very extensively in the United States and Germany. And the AstraZeneca vaccine, because it was originally a University of Oxford vaccine, was very widely administered in the UK. But if you look at immune responses and efficacy, all of the vaccines are very efficacious, but the mRNA vaccines have close to 95% efficacy versus the AstraZeneca vaccine is about 60 to 70%. It was also shown that the antibody titers to the AstraZeneca vaccine dropped significantly over time compared to the mRNA vaccines. I think, it's because they were not anticipating how strong the mRNA vaccine, how strong of a response the mRNA vaccines would generate. It's really a positive story and a very strong, clear indication of, very good immunity. But even after the mRNA vaccines, the antibody responses do decline after several months. I didn't realize that now in the UK, again, it may have been also just getting emergency authorization approval in each of these countries, and that may have taken some time in the UK to get this approval. I didn't realize that now they are recommending, or most people are getting the Pfizer, BioNTech, and mRNA. I know because of the low temperature storage, it's been a challenge to have these vaccines be administered in lower income countries, because travel and storage at -80 has been very challenging.
Thank you, ma'am, for answering all the questions patiently and for giving us a lucid idea on COVID vaccines. It is indeed the need of the hour, and you have cleared the air of various myths by stating the facts. I now request Dr. R. Uma, Assistant Professor, Department of Biochemistry, to conclude the session. Ma'am, please.
Thank you very much for the opportunity.
Thank you so much, ma'am, for this informative lecture. And it was a very crystal clear presentation, including all the recent research publications related to COVID vaccines. Hope all the participants would have been enlightened about the role of T helper cells, B cells, cytotoxic T cells in triggering immune response against viral infections. And you have given a very good explanation about the mechanism of the vaccine's role in triggering the immune response, which includes a role of NK cells in viral neutralization and the role of complement proteins in opsonizing the viral spike protein. Indeed, it is a very informative lecture, ma'am. Thank you, ma'am. Thank you so much.
Thank you. Thank you so much.
Yeah, thank you, Dr. Anuja. Thanks for accepting our quick response and coming out for the international.
Ma'am, Anuja, ma'am, thank you. There are more questions posted in YouTube. We will mail it to you. Okay.
Sure. Yeah. Thank you. Yeah.
Thank you, ma'am. We will now move on to the next session. Healthcare is not a privilege. It's a right. It's a right as fundamental as civil rights. It is a right as fundamental as giving every child a chance to get a public education. Our speaker, Dr. Kavita Rajashekar, will now provide us with more information on the topic, Healthy Technology Assessment, the need of the hour to provide affordable healthcare system to the country. Participants, please post your questions in the Zoom chat box or in YouTube live chat. I now invite Dr. D.S. Pushparani, Assistant Professor, Department of Biochemistry, to introduce our speaker. Ma'am, please.
It's my pleasure to introduce to you our speaker for today, Dr. Kavita Rajashekar, Senior Scientist, ICMR. She has completed her PhD in Biochemistry from University of Madras. Currently, she is coordinating the Health Technology Assessment Program, Department of Health Research, and actively working for the implementation of informed policy decisions in India. She is now a part of the core team, which works on enhancing COVID-19 testing in the country to 25 lakhs per day. She has drafted the Surrogacy Regulation Bill 2020 and assisted Reproductive Technology Regulation Bill, Health Technology Assessment Bill, and also in the part of the team drafting the National Health Research Policy 2021. We are excited to have you here, ma'am.
Thank you so much for the wonderful introduction. Shall I directly go into my presentation?
Yes, ma'am, please do.
Can I share my screen, please?
You want us to share the screen?
I'm sharing the screen.
Okay, okay, ma'am.
Is my screen visible? Is my screen
started sharing?
Is the screen visible?
Yes, ma'am. Yes, ma'am. Now it is visible.
It's visible. So thank you so much to the organizers for providing this opportunity to actually understand how the healthcare sector provides affordable healthcare to the country. The topic, I will merge it with the topic of the conference, which is infection prevention. So I will also bring what were the steps that the government took for preventing varieties of infection. Not only COVID, it could be HIV, it could be HCV, it could be HPV. So how does the government take steps when it has a variety of stored information with us? So I start with the quote of Mahatma Gandhi, which said that it is health that is real wealth and not a piece of gold or silver. With this, India has a lot of challenges and opportunity. High quality, affordable healthcare to be provided to 1.39 billion citizens is a big challenge for the government. To tackle this, it needs to understand how new technologies can be implemented. How can the out-of-pocket expenditure for every patient or every population in India, which is about 65% now, can be reduced below 30%. It also has to understand how priority settings can help in achieving the sustainable development goals which have been put by the UN to have available health allocation for India. But we do have opportunities. India is committed to enhance the healthcare spending to about 2.5% GDP. Make in India incentives have seen a big jump during the COVID sector. India also has a lot of difficulties in identifying what is the insufficient gap that is there and what is the inefficient wastage which is there, which was recognized as 20 to 40% of the healthcare spending is going wasted. It also identifies that 100 million people globally are still below poverty line. This was a study which was done by WHO, an OECD study which was conducted in low middle income countries, which said 1 in 5 portion of the healthcare sector goes wasted. With all these things in mind, we have to identify how resources can be efficiently utilized, how economic costing can help in this kind of a sector. My content today, I would go in identifying and introducing what is health technology assessment, where is it used, which are the technologies that can be assessed, and why do you need HTA? Health technology assessment is also a scheme of the Department of Health Research. HTA evidences have supported technology implementation, program implementation, health benefit packages. The biggest Ayushman Bharat program, which is called as the Pradhan Mantri Jan Arogya Shri program for the below poverty line people. How is this being designed? How is internationally people commuting and how other countries also refer to health technology assessment and utilize the evidence in their healthcare sector? So I go to the first one, which is Introduction to Health Technology Assessment. Compared to all the researches that is being done by the basic researchers and the clinical researchers, HTA is going to be slightly different. Now, HTA actually analyzes systematically all the properties, effects which have been generated by the basic science community, the clinical science community, the economic community. It brings in all this in one platform, identifies a technology based on its clinical effectiveness and cost effectiveness. It also identifies every technology by the incremental cost effective gain that that technology will provide to the government. This will help in providing affordable healthcare to the government with the limited resources that is available. So it is actually evidence-informed decision making for the policymakers who are sitting there in the health sector to govern and provide affordable healthcare. So which are the health technologies that can be benefited by this assessment? So we can have diagnostic devices, we can have medical devices, we can have artificial intelligence, IT interventions, programmatic interventions, surgical interventions, standard treatment guidelines or standard of care guidelines, medicines, drugs, vaccines, and health benefit packages. When is HTA used? So many of you must not be knowing this. When a technology is being developed and it is going to be implemented by the health sector, it needs regulatory approvals by a system called as the CDSCO, Central Drug Survey Committee, which actually gives the regulatory approval. We do not come under the regulatory approval. So the regulatory approval is given whether to know this drug or the technology is safe or beneficial. But HTA is actually being provided, or it gives evidences to support that the safe technology is also cost effective, that can be implemented so that more population can be covered under that technology. WHO actually identified what is the difference between a regulatory authority and the health technology assessment. So the regulatory authority actually looks safety and efficacy. HTA looks at cost effectiveness and clinical effectiveness. Regulatory is mandatory. Many of the countries still do not take the comparative recommendations of HTA. Regulatory authority is actually required to prevent harmful effects of any technology, but HTA is required to identify the technology, whether it's going to be affordable for the healthcare. With all these things, what is the role of HTA? Where do we actually implement it? Any new technologies, for example, during the COVID care, there was RT-PCR testing. There were testing which were called as the next generation sequencers testing, the CB-NAT, the TrueNAT, the antigen testing, the antibody testing. Are these technologies required for the system? Earlier technologies which were implemented, if they are obsolete, we need to remove them. How do you prioritize a health program? How do you actually float a health benefit package for the country or the state? How do you efficiently allocate the budget that is required and that is present with them for all the needs of the population? How do you cost a drug? How do you actually identify the standard treatment workflows which are required for universal health coverage? Why do you require HTA as a separate scientific body? So we have hospitals, we have academicians, we have research committees. We have pharma industries, technology, startups, scientific departments. All of them generate evidences as a singular platform. We bring in all the platforms that have been developed, no wet labs. So we look into a systematic analysis of all the evidences that have been published or the evidences which are available in a real world development or evidence. We systematically analyze them, understand what is the clinical effectiveness of that technology, what is the cost effectiveness of that technology, so that it can be implemented in an unbiased way for the health sector. Next, I will tell you how HTA became a scheme of the Department of Health Research. Department of Health Research is a department under the Ministry of Health and Family Welfare, which is a central government ministry under the privilege of Mansukh Mandavia, who is the Minister of the Union Minister for the central government. The National Health Policy said that we should actually look at health technology assessment, and this assessment should be provided to every technology. HTIN was established as a scheme in April 2017. It was floated as a project. The Parliamentary Standing Committee, when it is a ministry, the Parliamentary Standing Committee looks at how does the scheme or the project function. And they said this is a very important scheme. This should be taken up into the next level. A working group of ministers were also being appointed who recommended that this should become a central agency for all the affordable healthcare in the country. The journey continued. It became into a scheme in June 2021. The structure is, we have a medical technology assessment board with Vinod Paul sir, who is the member Niti Ayog as the chairperson. We have technical appraisal committees with Professor Sundaraman, who is a retired professor from JIPMER as the committee member, as a committee chairman. We have members as economists, epidemiologists, statisticians, basic science people, clinical research people. We extended our arm and we said we will have resource centers all over the country where we will develop health technology assessment capacity all over the country. We have 17 resource centers and 10 technical partners. We have completed about 20 studies which have been implemented by the state and the central government. 43 studies are ongoing. We have 26 states which can become a part of the health technology assessment for the implementation of the program. We do not, like all the other scientific bodies like DBT, DST, ICMR, we do not call for applications. We only support the state and the central government. They provide us the topic. We look into the topic, we identify what is the need of the topic, how the topic can be developed. So scientifically, how a topic goes into a research proposal, how that evidences are supported to make it into a policy. This is the pathway that we usually follow for its implementation. So I go into the next. Now I will tell you how evidences have been generated and how they will be implemented into the sector. I take 3 examples. I'm going to tell you a technology that actually helped in preventing infections, a program that actually helped in preventing cervical cancer, and the health benefit packages of Ayushman Bharat, how they were programmed. So I start with the cost effectiveness of the safety engineered syringes. Syringes must be a small thing that must be looked at by researchers, but actually India contributes to 25 to 30% of global injections. The frequency of injection, bone, blood,
Participants, please wait. It seems that ma'am has some technical issues. Sorry for the inconvenience. Participants, please wait. Ma'am will join soon. Kavita ma'am, can you hear me? Ma'am, your screen is visible, but you're not audible.
Screen is visible.
Yes,
Is my screen visible?
ma'am. Yes, ma'am, it is.
Yeah. Sorry for the inconvenience. I apologize for that. And so the potential solution. We were talking about the SETI engineered syringes. Am I audible?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah. The potential solution is we were using disposable syringes. So the disposable syringes in many sectors were again and again used, and they were used with the same needle and the syringe. So we have a solution which is called as auto disposable syringes, reuse prevention syringes. So what will happen is that once the plunger is put inside and the solution is released, the plunger cannot be pulled out. So automatically the syringe gets locked up. There is a small sheet which goes above the needle, and the needle also cannot be used again. So these are sharp injury prevention needles, and we have reuse prevention syringes. So these were introduced in the market, and the health sector government came to know that these were introduced in the market. So we looked into WHO's recommendation, and it said you should be started using it. But in India, without evidence, government doesn't introduce these things. So we said, let's do a study on this. So we wanted to assess the incremental cost per quality of life that will be gained by introducing safety engineered syringes along with reuse prevention needles and syringes together or as individually into the therapeutic sector of the government. What will be the fiscal implication that we require if we have to implement this kind of a thing in the budget of the healthcare sector? Because every time there is a budget that is allocated, the healthcare sector in the beginning of the year prepares and plans what it is going to be used. So when we do not have a new budget for safety engineered syringes, we could not implement it. But how do we do studies? So when we have these studies, people who are doing systematic analysis know. They check in all the databases that are available for safety engineered syringes. We got about 801 papers. Then we identify what should be our inclusion exclusion criteria to identify which paper fits into your decision making, which paper is conflict of interest which has to be removed. Papers which are published by the manufacturers, papers which are not randomized clinical trials, papers which are clinical effectiveness trials, they will all be picked up into evidence analysis. So like that, we picked up 12 studies for qualitative analysis and 8 studies for quantitative analysis. This kind of a chart is called as a Prisma chart. All the people who are doing systematic review will know this. This is peer reviewed. We do a checklist for this, and then we analyze what is the data that is available that can help. For initially when I showed you slides, we said that needle prick injuries can cause hepatitis C, hepatitis B, and HIV infections. We did not take the complications that are associated with sepsis, with neonatal deaths or mortalities. So we looked at this kind of a model is created for hepatitis C virus. We create such model for every virus and every disease that is considered into the modeling of that particular technology. For this technology, I'm just showing you one model for hepatitis C. So when you look at the model, you first identify with a disposable syringe and with a safety engineered syringe. When you compare both of them, what are the things that will help you? So you have dark red lines and you have dotted red lines. So when you have dark red lines, you do not have a safety engineered syringe. You only have disposable syringe, which can actually lead to a person who can be an asymptomatic carrier. He can actually cause chronic hepatitis. He can cause cirrhosis. He can cause undecomposed cirrhosis, hepatocarcinoma conditions, and these can all lead to death. But on the other side of dotted line, if you're going to use safety engineered syringes, what will happen? Person to person transmission can be stopped. You will stop, even if he is going to be an asymptomatic carrier, he is not going to transmit the disease to another person. So automatically he will not progress. He might progress, but he will not transmit the disease to the other person. Death levels, infection levels in the country will automatically come down. This kind of a model is also generated with the evidences that are available as a part of literatures, as a part of real evidences which are available in hospitals, in research institutes, and so on. When you analyze cost effectiveness, you actually identify the new technology, how many cases with a disposable syringe you were able to generate. That is, hepatitis B virus, if it could be so many infections with the disposable syringes were being generated every year, the safety engineered syringes, those infections can be prevented. So that is the first category that you identify, how many infections you will be able to prevent per year in a per lakh population. Then you identify what was the cost of the treatment that was associated with a disease condition, without a disease condition. Third thing you identify, a person, if he has not got an infection, what is the quality of life he will gain? And with that quality of life, he also gains some years to his life that he is going to live. So with that, you identify the incremental cost gain. So the cost per quality of life index will give you the ICER range. This is just a chart to show you that the reuse prevention syringes actually gave us the maximum cost gain. The sharp injury prevention syringes or the RUP plus sharp injury, they did not give us a cost gain. So if it is not going to give you a cost gain, what is the use of implementing that kind of a technology into the healthcare system? So, but then we do one more thing. We definitely need to introduce them. The initial cost of safety engineered syringes were about 25 rupees per syringe. We said, let us do a cost threshold analysis. If we say, if it is going to be below 1.9 rupees or both of them together, if they're going to be below 5.4 rupees, they will be cost effective. This was told to the government. Punjab government procured it at 1.5 rupees per syringe, and that was very affordable for the whole state. The same thing has been reproduced during the period of vaccination, where we have auto-disposable syringes for the complete vaccination program in the country. This will not only help in giving vaccination prevention, but also prevent blood-borne infections. When you look at the budgetary analysis, I initially told you when we have a lesser budget, we need to understand what extra budget that you need when a new technology is going to be implemented. When we identified if you're going to procure it only at 1.4 rupees per syringe, we required an only additional budget of only 1.8%. With this, Punjab, Tamil Nadu, Kerala, Karnataka, Delhi, Punjab, central government hepatitis program, all of them implemented the safety engineered program into their guidelines. So this is how affordable healthcares are being implemented by the healthcare system in every new technologies that are coming into the system. So with this, I already told you Punjab implemented. So a government order is issued by Andhra Pradesh which says health technology assessment was being done for safety engineered syringes. We bring it to the complete public health system. The national guidelines for hepatitis control also implemented in their guidelines program. The next evidence I'm going to show it, how is a program being implemented in a healthcare sector for prevention of infections. So we take into cervical cancer, which is the largest cancer which is causing mortality in the female category of the country. The questions that we ask us before we start a research is what population should be catered to? What is the intervention? What comparators we have to look at? What will be the outcome of this study and what should be the timelines? Our studies do not go beyond 8 to 12 months. We complete the studies. More, if we have all data with us, studies are completed within 6 months so that the government implements it at a faster pace. When we had to roll out a program, how do we strategically screen cervical cancer patient in the country? We had 3 options: visual inspection with acetic acid, the pap smear, which is the cytology test, the HPV DNA, which is a molecular biology test. So with this, we moved on. We said we will look at effectiveness. We will look at the cost of screening and the treatment. The cost effectiveness, like a Marco model that we did for the safety engineered syringes, we also did modeling for the cervical cancer screening also. Equity, whether the whole country will be benefited by this or only a smaller population will be benefited by this. With the complete study, we identified that screening with visual inspection with acetic acid for 5 years with the population of 30 to 65 years is going to be the most cost effective, which reduces mortality, which reduced death in the population of 1 lakh population that we screened. It also reduces the out-of-pocket expenditure, which is very high in cervical cancer treatment. It also went into the Ministry of Health and Family Welfare Cancer Prevention Guidelines. This is how guidelines are being developed in the central government that is rolled out for the whole country. Now, I will be talking about health benefit packages of Ayushman Bharat, how they were rolled out. So there are about 1,500 packages. It could be cataract, it could be gastrointestinal treatment, it could be bronchitis, it could be PTCA with stent, it could be cardiology treatment, neurology treatment. How do you identify what will be the cost of each package? So we did one of the biggest study, in fact, in the whole world. We did a study in 16 states. We started the study in 2018 where we covered 86 hospitals. Every hospital data were collected to unit cost. For example, a doctor who's working in the operation theater, his salary. If he performs a surgery for about 2 hours, his salary is unit costed for that 2 hours. I'm a patient, I'm going for my cataract surgery. So I need diagnosis, I need OPD, I need follow-on, I need drugs. So everything is treated and the cataract whole package will be about 8,000 rupees. This is how the national costing study helped in package revisions and package identification for the biggest Ayushman Bharat health benefit program in the country. This has been published as data. Data are all available online. We published our data in PLOS, in BMC, in Nature journals, and so on. These are all the studies that we have done. So we look into medical devices, health programs, diagnostic devices. So our TrueNat, which was a TB testing program device which we identified and implemented in TB program, we repurposed it during the COVID program to support the COVID testing. Drugs. So we looked into long-acting reversible contraceptives, which could be a part of the family planning program. The surgical interventions, whether PC, your stents are cost effective or open bypass surgery is going to be cost effective. So we did studies on that also. So point of care facilities, digital hemoglobinometers are cost effective, or still your autoanalyzers are going to be cost effective. We supported during the pandemic time also, during the purchase of high throughput machines. We said they are not cost effective, so we stopped the budget that were allocated for them and we repurposed for the RT-PCR testing, which was going to be very cost effective. I'm going to just quickly tell you that HTA has supported affordable healthcare implementation in our country. Now, this has to be centralized. This has to become a big agency to support the whole country because every country is equitably different in India. How did internationally we looked at them and how did we bring in best practices that were there across the world? Across the world, there are 60 countries which have health technology assessment programs, which not only works for preventing infection, but they help in identifying affordable healthcare. This was one that was called by WHO to implement it in all its health technology, HTA programs and all its healthcare interventions. NICE was one of the first and the foremost one which started its health technology program in 1999. NICE is National Institute for Center for Excellence, which is set up by the UK by its healthcare setup. This became into a legislative body as a part of the Health and Social Care Act. It became mandatory. It became an independent public body that supported so many countries and also supports the National Health Services of UK. HTA became a major tool for priority settings in majority of the national governments. You can see Philippines adopted it as a legislative body. Indonesia adopted it as a part of their healthcare system. The European Parliament passed a legislation that HTA should become mandatory. US used it for private insurance companies. South Africa, Korea, Australia, we have so many countries which utilize it for the procurement of affordable healthcare for the population. I end my talk by some of my publications which are part of the HTA. We have about 89 big publications, but these were two big studies that we published in BMC and in BMJ, plus in Applied Health Economists. We also have done the Eurocall, the Quality of Index for India. This is one of the first to study, and we are the 13th country to publish the Quality of Index, a utility value for India, which is required when you need to identify which health intervention should be prioritized in India. Thank you so much to the organizers for giving me this opportunity to showcase what HTA is and how the youngsters can be benefited by this, how states can be benefited by this. Thank you so much to all and the organizers.
Thank you, ma'am, for enlightening our knowledge. Now it is open for questions. Does anyone have any questions? There is a question in YouTube. What are the recent strategies adopted to improve the quality of healthcare in India?
This is a vast question. The quality of healthcare doesn't just be diagnostics. It is not technology. It is not treatment. So the first, for quality of healthcare in India, every state and every central government has quality control guidelines, which is called as the standard treatment guidelines. So we have done it for about 195 packages. We are continuing it. Our target is by this year end, we should be doing it for all the 1,500 Ayushman Bharat programs also. So that will assure quality also and reduce the out-of-pocket expenditures also.
Thank you, ma'am. There is a question in the chat box. How technology is changing healthcare in India?
So let me take the example of COVID care itself. So technology actually changed the COVID care. Nobody actually initially, the literate and the illiterate population didn't even know about RT-PCR. Today, even a rickshaw person knows what is RT-PCR, and he knows RT-PCR is a valid test for COVID testing. So technological development, indigenization of these developments in India has actually propagated the knowledge across the scientific forum also and the non-scientific forum also.
There is one more question. What are the steps taken to provide quality and affordable healthcare for all the sectors of people with respect to their financial status?
So I repeat the same point. The Ayushman Bharat program is now rolled out only for below poverty line people. For the other class of people, state governments roll out programs. From the central government, we do not have programs at present. For the middle class or the higher class people, it is only for a program. Our aim is to have universal health coverage when it will move on to the next quintal of the population. Now it is below the population line only.
Thank you for answering all the questions patiently, ma'am. Does anyone else have any questions to ask? So I guess no. Yes, we have one more question. We learned that biomedical waste has become a major threat of infection. What are the measures taken to curb it?
This is a very good point. Not only biomedical waste, we also have research waste. So it is a big point for the environmental thing. The Ministry of Environment takes care of this biomedical waste management. Along with the Health Ministry, we have a guidelines, and every fortnight, states have to actually send us the report telling that how are the biomedical waste being managed. The management waste guidelines is available on the MOHFW website also, and also available on the Ministry of Environment website. Yes, how much are we following? Because there is no penalties or penalized provisions for all these things. Still, there is biomedical waste that is being thrown and hazardous effect of spreading infections. This point will be taken. I think this will be a very good point that the Health Ministry looks into it and brings in more stringent guidelines into it also.
Thank you so much, ma'am. Thank you so much, ma'am, for sharing to us your knowledge and expertise. That was indeed an insightful and relevant presentation. You have started with a speech that wealth not lies in the pieces of gold and silver. You have explained clearly what is HTA and why HTA is needed. Indeed, it's really the need of the hour to provide affordable healthcare system to the country. Your thoughts are going to stay with us, of all of us. I hope everyone would have found this speech more informative and useful. Thank you so much, ma'am.
Thank you so much. Thank you so much to the organizers to bring in so that the younger population need to understand how healthcare is being prioritized and what are the steps that people are taking in to bring into good value for the money that they are spending.
Thank you.
Thank you, ma'am. Now we are moving on to paper and poster presentation. Science is a beautiful gift to humanity. We should not distort it, by Dr. APJ Abdul Kalam. We have participants who are eager to present their papers and posters with us. Do remember that you have only 5 minutes to present, and 1 minute will be for questioning and answering. I will now read out the names of the participants. Please acknowledge your presence in the meet, either by raising your hand or by posting a message in the chat box. Dr. Sandhya Tambika, Nirubama Kumar, Purnima Shyam, Nagi Teja Reddy, and Ramya M, Rita, Chandraprabha, Febi, Shalini, Dr. T.S. Subhashini, Jagatish, Prasad, Sureka, Parat, Smriti Bajpai. Meanwhile, I would like to invite Dr. Sangeeta Satyanarayanan, Assistant Professor, Department of Biochemistry, to introduce the chairperson, Dr. Vijay Srinivasan. Ma'am, please.
Vijay, ma'am, video on. A very good afternoon. Vijay, ma'am, can we see you? Ma'am, can you please turn on your video, ma'am?
Yeah.
Thank you, ma'am. A very good afternoon. Maybe not afternoon yet. We are 5 minutes ahead of the schedule. Good morning. I take pride in introducing the chairperson for the third session of scientific deliberation, Dr. Vijaya Srinivasan. Ma'am is an associate professor in the Department of Biochemistry, Sri Ramachandra Medical College and Research Institute. She has been with this institution since 2003. When asked to share her CV, we received a document that was 8 pages long. A list of her credentials are not only long, they speak volumes about her achievements and her contributions to the area of teaching as well as research. But I'm not going to read the entire thing. I'm making it very brief, sharing with the audience only those which I'm sure will inspire the young minds in the audience. Madam holds an MSc in medical biochemistry from the Madras University. Has been a bright student right from her childhood, maybe. Secured the 4th rank in her post-graduation, which she completed in 1987. In 1988, she qualified for the much meritorious Junior Research Fellowship through the entrance exam CSIR, UGC CSIR in Life Sciences, which is a dream for many of you here. In 1988, she was selected to be the new Junior Research Fellow in the Department of Biochemistry in the Indian Institute of Science, Bangalore. In 1989, she joined as a Junior Research Fellow in a project entitled Environmental Carcinogens and Tumor Growth Promoters, which was sponsored by the Ministry of Environment. In 1990, Madam received the Young Scientist Award for her research paper entitled Role of Ischemia in Urolithiasis at the 5th National Conference on Urolithiasis held by USOI at Meerut, UP, India. In 1993, she received yet another Young Scientist Award for her best paper entitled Oxalate Retention in Ischemia, Reperfused Kidney at the 7th National Conference, again organized by the USOI, this time in Chennai, India. Ma'am has completed her PhD in the year 1994, highly commended from the Madras University, after which she went on to do her postdoctoral fellow at the Bayer College of Medicine, Houston, Texas, USA, between 2001 and 2003. During this period, that's in 2002, she received the McFarlane's Award for the best oral presentation of her research entitled Hypoosmotic Stress-Induced MAPK Signaling in HepG2 cells via extracellular ATP. At this point, I would like to say that she was my teacher. Maybe we were her first batch of students when she joined Valliammal College after her doctorate. A very passionate teacher and a researcher. After so many years of teaching and research, she still continues to deliver guest lectures in reputed organizations. She's been working in NABL accredited lab for past 13 years and is proficient in preparation of NABL accreditations. Usually once we come to teaching, research takes a backseat, but that has not happened with Vijaya ma'am. She continues to publish papers in national and international journals of repute. She's a doctoral committee member for several PhD candidates. She's a reviewer in the International Journal of Clinical Biochemistry and Research, for which she has received the Certificate of Excellence for reviewing papers from the year 2016 till date. Her expertise in teaching include fields like analytical biochemistry, immunology, enzymology, biotechnology, medical biostatistics, nutritional biochemistry, and the list is long. Her recent accomplishments include Best Poster Award for her poster entitled Think Probabilities, Not Possibilities in Research, which she presented at the 7th National Conference on Research Methodology held in December 2019, organized by the Institutional Research Board and Medical Educational Unit, Trichy SRM Medical College. Ma'am, it's a great honor having you in our midst, and I'm sure that the participants and the audience will gain to know a lot of things through your scientific deliberations. Over to you, ma'am.
Vijaya ma'am, are you there? Shall we start, ma'am?
Yes, very good afternoon. Thank you very much, Dr. Sangeeta, for a very kind introduction. I'm greatly delighted to be the chairperson of this international conference, paper and poster presentation. I hope all the participants are well aware about the rules of presentation. Kindly keep up with the time, and without much yeah. So without, am I audible? Am I seen, Sangeeta?
Yes, ma'am.
Okay. So without much delay, I would like to call upon the first speaker, Dr. Sandhya Tambekar, to start the presentation. Over to you, ma'am. Am I audible? Can you hear me?
Yes, ma'am.
Yeah.
Dr. Sandhya, are you there?
Yeah, unmute pannuva solren. Vijaya ma'am,
Yes, ma'am.
we have checked for the presence of participants, ma'am. So we'll just call them in the order that they are available in the Zoom link, ma'am.
Okay, fine. You just tell me the abstract number.
Yes, ma'am. Yes.
Yeah.
The first part. Thank you, ma'am. Participants, do keep in mind that you only have 5 minutes for presentation. At the end of the 4th minute, there will be a small bell, and after the 5th minute, there will be a large bell, after which you will be muted. The first participant is Nirubama Kumar, who is presenting a paper on the topic evolution of pharmacological activities for production and purification of bioactive compound saponin from Piper-Nigam root, a green approach. Number 22.
Yes, so most welcome, Mr. Nirubama Kumar. So we welcome you, sir.
Good afternoon, ma'am. May I audible?
Yes, yes.
Good afternoon to all and all present here. I am Dr. Nirupama, Assistant Professor, Department of Biochemistry, Kongrad Arts and Science College, Coimbatore. My topic is evaluation of pharmacological activities for production and purification of bioactive compound saponin from Piper-Nigam root, a green approach. Ma'am, it is visible, ma'am?
Yeah, it is visible, ma. Please continue.
So India is the largest producer of medicinal plant, and rightly it is called the botanical garden of the world. Medicinal plants are nature's priceless gift to human. Piper nigrum is widely utilized in ancient medication in several countries of the treatment of many diseases like fever, dysentery, jaundice, etc. Useful spices like pepper have a crucial role in native economies by supplementing the native diet and going in ancient therapies. Piper nigrum is considered the king of spices throughout the world due to its pungent principle, piperine. Piperine is an organic compound and it is an alkaloid compound. It is very active compound in the Piper nigrum. It is having the tremendous biological activity and pharmacological activities also. The peppercorn of Piper nigrum has a whole or its active components are used in most of the food items. Different parts of Piper nigrum, including secondary metabolites, are also used as drug, preservative, and natural control agents. This plant provides scientific basis for traditional use of tarragon for treatment of pharmacological activities. So this is the plant kingdom of Piper nigrum. The family is Piperaceae. Already I told it's have the Piper nigrum, it's having the tremendous pharmacological activities like anti-cancer, hepatoprotective, antibacterial, and anti-cough, hyperlipidemic. Then it's treat with piles also, and it improve the digestive and digestive system, and it improve the appetite, anti-inflammatory. So wide varieties of the pharmacological activities are, so that's why it is called as a king of spices. So the objectives, the following objectives were set up for the study. The first phase, the several extracts of Piper nigrum were probed for the phytochemical analysis. In the second phase, isolation and separation of saffonin from Piper nigrum root. In the third phase, the antimicrobial activity evoked by the methanolic extract of Piper nigrum root were studied. So the standard procedures were followed by this methodology: phytochemical isolation and purification of Piper nigrum and antimicrobial activity of Piper nigrum root. So the results it shows in the phytochemical analysis, we have taken for different extracts like aqueous, methanol, benzene, petroleum, ether, and chloroform. The most bioactive compounds are present in the methanol extract. So the further studies we have followed for this methanol extract. So this is a diagrammatic representation, shows the phytochemical screening analysis of methanolic extract of Piper nigrum root. Then the quantitative analysis, the concentration of total phenol and total flavonoid, it should be present 10 milligram and 14 milligram in the methanol extract of the Piper nigrum. So the general procedure, it followed by the saffonin from the plants. First, the root of the plant, the Piper nigrum root of the plant, it should be blended with powder, and it is defatted with hexane or petroleum ether by using of the Saxlate apparatus, and it is transferred to the methanol, and it is concentrated with the diluted water, saturated with by adding of the N-butanol. All the solution, it should be transferred in the separating funnel. The 3 layers, it should be obtained. The center of the layer, the add for diethyl ether to precipitate for the crude saffonin mixture. We are collecting for that crude saffonin for our further studies. So this saffonin, it's also having the biological activities, that is the pharmacological activities, anti-cytotoxic, hyperlipidemia, anti-inflammatory, anti-fungal activity also. So this is a diagrammatic representation, the isolation and purification of the saffonin from Piper nigrum. So the confirmation test for saffonin is the froth test. It is only the screening analysis. So the confirmation test, the froth, it will be obtained for just 5 minutes, 2-3 minutes, it should be obtained. It is a confirmation test. It is only for screening analysis. It is not a confirmation. So the other studies, that is the TLC and HPTLC, we go for further confirmation in the future. More particularly, they are amphipathic glycosides gathered phenomenologically by the soap-like froth create when shaken in fluid arrangements, and basically by having one or more hydrophilic glycoside moieties combined with a lipophilic titopherin or steroid derivatives. So why I have chosen for saponins means that in the Piper nigrum root, the root it will have rich in the saponin. Then it is a blooming concept nowadays. The pharma industries it is a blooming concept of this saponin. So the saponin is the antioxidant bioactive compound. So what are the health benefits of saponin means it is an immune booster, natural antioxidant, and reduce cancer risk, cholesterol reduction, and reduce bone loss. So all this the activities it should be present in the saponins. That's why I took for the saponin for my work, for my research work. Then we move on to the antibacterial activity of methanol extract. There are 4 different organisms we are taken for this microorganism. The zone of inhibition to compare for this control antibiotic. The zone of inhibition it shows to the nearer control near the value of the control. So this is a diagrammatic representation of the various organisms. So we, in summary, the phytochemical screening of methanol extract of Piper nigrum, it reveals to the presence of bioactive compounds such as alkaloid, phenol, steroids, flavonoids, tannin. Thus, the phytochemical screening test may reaction of the bioactive principle, and subsequently it may lead to the drug discovery also. So based on this study, it shows the extract of the Piper nigrum root have shown good antimicrobial activity of some selected foodborne bacteria. All the compounds from extracts of root show broad spectrum antibacterial activity against the bacterial organism. So this study reveals the root extract of Piper nigrum in having the antimicrobial agent. Also, the present study can as a plant extract from root has many functional groups which can be further used to develop many novel therapeutic agents in future. The recommendation also the cell line study and animal model in the human clinical trials and standardization of the drug. So the future recommendation, the studies will be carried on in future of my research work. So thank you. Hounds heads having more antioxidants than any other food group. Thank you, ma'am.
So thank you, madam. It was a good presentation. My only one question is, what happens? How does it get metabolized? Have you done any study to show that this? What happens to the saponin, either in rodents or in humans? Have you done that study? Any study? Because you say it is so therapeutic. So, have you done any studies regarding that?
No, ma'am. In future we will do, ma'am. Only the.
Then how do we establish that you just have done the antimicrobial activity of the saponin?
Yes, ma'am.
Now, if it has to be used for general, medicinal uses or so, what have you done for that?
The saponin is already, it is a good for antioxidant, ma'am.
Then what is new about the study?
The new means the root of the Piper nigrum of the root, it is having a rich of saponin. So the Froth conformation test already done in phytochemical. So it's done for in the antimicrobial activity, ma'am.
Okay, madam. I think you have not reached the question what I have asked. So you could look on to that. You could further studies could be made on that angles, madam. Okay, madam. Thank you.
Okay,
thank you, madam.
Ma'am, thank you, ma'am. Vijaya ma'am, with your permission, I want to make one small announcement clarification here.
Yes, please. Yes.
My participants by names Sandhya Tambedkar, Nagi Reddy, Nagi Teja Reddy, Shalini, Rita, Farhat Mateen, Smriti Vajpayee. We can see all your names among the participants on Zoom link, but you haven't confirmed your presence in the chat box. Are you ready for the presentation? If you are ready for the presentation, please put a message in the chat box saying you are here and you're ready for the presentation. In the meantime, call upon Purnima Sham, next presenter.
Can you tell me the abstract number, Sangeeta?
23, ma'am, on the topic omics in cervical cancer.
Right.
Ma'am, am I audible, ma'am?
Yes, you are audible.
Okay, ma'am. 1 minute, I'll just start the screen share. Good morning, ma'am. The topic of I'm a research scholar from Madras University doing my PhD in Regional Super Specialty Laboratories under the guidance of Dr. S. Subramaniam. The topic of my presentation for today is omics in cervical cancer diagnostic and treatment, a method-based review, ma'am. Omics is nothing but an integration of proteomics, metabolomics, genomics, and other interpretomics and other fields where you bring in together all possible traits to evaluate a disease as a whole. So a cell, as we know, is made out of proteins, genes, DNA, RNA, and that is called a multiome. So the topic for today is the omics is the integration of, as I said, genomics, proteomics, metabolomics, and metagenomics, transcriptomics. A complete genome profiling figures out actionable molecular alteration and the goals for many cancer subrests. That is called as interpretomics. The technology that measures all the constituents of a cell to bring together and integrate disease is omics. So exploring disease-based association by using omics and clinical information helps us to improve our current knowledge and also helps with diagnostics, prognosis, and treatment. Cervical cancer, the topic that I have taken, is ranked 9th in the incidence as well as mortality. In India, there's an estimation of 96,000 new cases, out of which there is 88.4% of deaths. And cervical cancer forms in the inner lining of the cervix. E6, E7, L1, and L2 proteins are prominent from the HPV. And cervical cancer is both of a viral nature as well as non-viral nature. So when you go into omics, each of them, see if you say genomics, we're going to take DNA profiling, genetic mapping, recombinant DNA technology, all of that together. Proteomics is what proteins are involved. Metabolomics is how these proteins, genes involved with cancer as such and make a difference. So these are the common steps of omics in the type of presentation I'm trying to make. So the steps involve where you take a protein or a DNA of interest, blast them together from various organisms, because I'm dealing with different types of organisms or strains. Different types of organism or strains. So after blasting it, we study the families or the classification of how the evolution has taken place. Then if you see if it is an evolution has taken place based on the protein or not, then protein modeling is taking place. And then you would go into a database like KEGG or WIT and see where these proteins or DNA plays a role in this cancer making. So in case there are various integrated factors, that is, you have you have your blood factors, you have molecular factors, all of them together, we can make statistical modeling. And this statistical modeling will be a very good prediction tool for seeing the disease prognosis as well as how the treatment is going through. Interactomics is recognizable as a large scale analysis of gene to gene, protein to protein, and protein ligand interaction. David is one that will help you to pick, is a part of this omics, and it is a software that will help you pick and view any of these genes or proteins from these pipelines. So this is the omics tools. Generally, you have metabolomics, targeted gene therapy, shotgun, and depending on what type of analysis you need, you can use these tools of omics. Cervical cancer and omics, I've just, because I've said a review, I've taken what work, latest of the works that are being done. There is a work done by Aden et al. Where they have taken the data from the cancer genome atlas, matched with the patient records, and they have taken proximity of integration sites and few sites they have taken, integration, deductor, and genes they have taken. And from that, they have found BNC1, RSBN1, USP36, and TOK3 are helping in integration of these genes and in the disease progression. So this potential pathway elucidation has been done. When you come into Modi et al.'s paper, that we will know that there's an understanding of HPV oncoprotein. So E6, E7 is the popular one, and in E6, E7 they help in P53 and retinoblastoma proteins to be stopped, and thereby there is no progression towards apoptosis. So immortalization takes place from this. So now if you see, there are so many genes and the consequent proteins being linked by using omics. They've used urine samples for checking for presence of HPV, the E6 protein in particular. And next generation sequencing has also been done where they have said that there is a possibility you can deduct it from the blood. Han et al. Has given a very advanced work where they have seen progression of cervical cancer by seeing the CpG islets. And they also say DMR and DHMR associated genes help with the overall survival of cervical cancer. This paper of Hugh et al. Shows the protein expression of FHIT and LRP1B protein down regulation helps with HPV. So this is just a model of how I have done with mine. This is a pathway from KEGG. In this pathway from KEGG, you will see the MAP kinase signaling pathway and JAK kinase signaling pathway, P53 blocking. So these are the 3 checkpoints. So I've taken all types of HPV that is available, done a blast search to see how there has been an evolution. And in that, we see that E6, E7 protein, L1, L2 protein are commonly present in all this. There is no evolutionary change there. Next is to target these specific genes, E6, E7, L1, L2, and that target protein, the proteins that they target is NF-kappa B, P13K, retinoblastoma protein, and P53. And the pathways is JAK kinase, MAP kinase. So in case we can block these, stop these pathways from being blocked or stop the promotion of E6 or E7 at any particular stage, we will be able to block the cancer. This, however, has to be integrated with cell culture and patient-based data, and only then we will get a holistic picture. Metagenomics and proteomics should be involved in it, and next generation sequencing of a few patients will show us where the disease progresses is taking place. And we have to test for specific molecular target and integration and mathematical. So if you say there is an increase in E6, E7 protein, or you say there's an decrease in P53 protein, all of this together with a mathematical modeling will help us derive at a tool that can be that will help in prediction along with the figure stating of the patient. So in conclusion, omics can be effectively used to predict staging and progression of the disease. Cervical cancer is a viral-based disease and progresses very slowly from infection to cancer. So it is possible by using these tools and regular screening that we will be able to prevent the patient from reaching a cancerous stage or death. However, the quantum of data that is needed, we cannot go with very little data for this, and including NGS and things like that. So it is time consuming, but you can establish. These are my references, and thank you, madam.
Okay. So it was a good presentation, Purnima.
Thank you.
It was a detailed presentation, of course. But what is the carryover message? Now, have you done this, like you are preparing a model, right? A structural model.
Yes.
Have you established this using a simulation? Have you done it?
No, ma'am, we've gone only till stage 3 where we're checking the protein and doing some docking work there, ma'am. And cell culture work is also on the pipeline. But the integration of the data part of it, we've not started yet, ma'am. So this is just, that's why I had given it as a method-based review, ma'am, because I don't have the data from that part of the work.
Yeah, that is what, one of the important aspects that I would like to have is the data. If we have the data, so yes, that would be great.
It is on the progress, ma'am. We are doing cell culture based to see these same proteins, L1, L2 proteins, because L1, L2 will show us the progression of the disease or how far, once L1, L2 starts getting secreted by the virus, that means they're establishing. So quantification of those proteins as well as the checking of the P53 regulation by Western blot, that is under progress, ma'am, but not per se. I don't have the entire data of few passages. I just have 1 or 2 passages. So that would not be relevant. So I'm not ready.
Okay. And then the other question is, why have you chosen P53? And you have also done on junk. But why particular that? Then in the case, if you are doing MAP kinases, you could have even selected ERK. Now, what prevents you from not selecting ERK, which is one of the major MAP kinases?
Ma'am, we just selected the pathway which leads to immortalization, ma'am. So P53 was prominent there. MAP kinase pathway, we've not gone in very deep, in depth to see into which they are preventing, ma'am. So I'll take your suggestion and I will take Merck and I'll check, ma'am. I will check the upregulation also. Thank you for your suggestion, ma'am.
Thank you.
Participants, please do adhere to the timings. The timings for the presentation is only 5 minutes. The next presentation is by Purnima Shyam. The next presentation is by Chandra Prabha, abstract number 26.
Abstract number 26. Dr. Chandra Prabha. Purnima over.
Dr. Chandra Prabha. Dr. Chandra Prabha. The next participation is Phoebe, abstract number 27.
Hello, good afternoon, ma'am. Am I audible?
Yes, yes.
I'm just sharing my work. Is it visible, ma'am?
Yes, ma. It is very much visible. Yes, ma. You are Phoebe
Paiva.
Paiva. Okay.
Yes.
Please continue.
Very good afternoon. Today I'm going to present my work, Role of Bioinformatics in Target Identification and Differentiation of Follicular Thyroid Neoplasms. Myself, Phoebe Paiva, Assistant Professor, Department of Zoology, St. Joseph's College for Women, Alapura. Follicular thyroid neoplasms are, in fact, the nodules of thyroid cancers, and it may be classified as malignant follicular thyroid carcinomas, FTC, and the benign follicular adenoma. And we can see that this follicular thyroid neoplasms, they share many clinical and cytological characteristics, and it is very difficult to differentiate the benign and the malignant varieties. And in fact, the majority of the thyroid follicular nodules are benign and hence need no invasive surgeries and thyroidectomy. And we can see that the prognostic treatment strategies used for malignancy is entirely different from that of the benign thyroid nodule. So therefore, being able to effectively differentiate the malignant from the benign nodule is very important and challenging issues to clinicians. So here lies my objective, is to understand the role of bioinformatics in target identification and differentiation of follicular thyroid neoplasms. The methodology I used was I adopted 2 data sets from the gene expression omnibus, and in the first one, they have compared the samples of 10 follicular adenomas with 13 FTC, and in the second one, it was 25 follicular adenomas with 27 FTC. So here it is these are the 2 data sets I chose, and the data from the data sets were processed, and here we can see that they were screened for the differential expressed genes from GO2R data web tools, and the consistently changing differentially expressed genes were being identified by the VENI tool, and the pooled differentially expressed genes from the 2 data sets were taken for the functional annotation and pathways enrichment with the tool enricher tool, and these differential expressed genes were being used for constructing the protein-protein interaction network using the string software of Cytoscape. And from this network, the highly interacting areas or subnetworks or modules have been identified by the ENCODE software of Cytoscape. And from these subnet, the modules, the hub genes, that is highly influential genes, were identified by the CytoHub software of Cytoscape. And from this hub genes, the target genes or the key genes were identified by a survival analysis being done by GPIA software. So the result shows that the 2 common elements were being identified was HIRA and the CBX7, and both were being analyzed to have its role in metastasis and cancer progression. And when all these differentially expressed genes from both the data sets were being pooled for a pathway analysis, the pathways came into existence were being the significant pathways were the mineral absorption, fluid shear stress, and atherosclerosis, followed by protein exposure, osteoclast, endocytosis, focal adhesion, etc. And this justifies the fact that based on the ultrasound studies of 2021 and all that, the the main differentiation of the FTC from FA was found to be the calcification, so incidence of calcification. So this can be justified by this. And when ontology studies were shown, it was seen that most of the molecular functions were related to the cancer progression, like activator receptor activities, and even the cellular components. We could see that they were being, and those which were being enriched were the endoplasmic reticulum, Golgi bodies, the vesicle transporters, etc. And when all the differentially expressed genes, that is 146 identified, were being pooled into this network, this is the protein-protein interaction network being formed, and from this the highly interacting subnetworks were being identified. About 7 modules were being identified, and 4 highly significant modules were being selected for this study, and this is the first one, module 1, with 8 nodes and 28 edges. Nodes are the genes and the edges are the interconnecting structures, and they were being analyzed with cytohub for identifying the hub genes. And the red, more the color, it shows the more the more significant those acting as the hub genes. So those with the red one shows that these are the hub genes. And in the second one, second module, we can see it is having 24 nodules and 58 edges. Third one with 14 nodes and 28 edges, and the right side one shows the cytohub analysis, and this is the fourth one with 25 nodes and 44 edges. And all the genes of the different modules were being analyzed for the gene ontology studies, and most of them were be seen for protein action, protein formation, and even the folding of proteins, and the cellular components which were being enriched were endoplasmic reticulum, Golgi apparatus, the transport vesicles, etc. And when and we can, and from the 4 modules, 28 hub genes were being identified, and from this 28 hub genes, they were again analyzed for the survival analysis. And from that, 8 key genes were identified. And these are the 8 key genes or the target which was been identified. As a conclusion, we can say that the deregulated pathways are the mineral absorption, fluid shear stress, atherosclerosis, and the 8 key genes are these one. And so transcriptomic data can be used for further our understanding about the pathogenesis of follicular thyroid neoplasm. But then independent validation is essential with larger replicant cohorts to apply it as for the clinical purpose. So the relevance is that over-diagnostic issues, unwanted thyroidectomy can be avoided. At the same time, this is a small step towards the personalized treatment methods. And these are the important reference of my work. Thank you.
So,
hello, ma'am.
Yes, Fabi?
Yes, ma'am.
Am I audible to you?
Yes, ma'am.
It was a good work, but let me tell you, as the organizers have already told, that you will not be allowed to go beyond the time. You will not be qualified. See, though you may have things. Okay, so that is a problem.
Yes,
so
ma'am, but then only first bell was rang. That's why I continued.
No, the second bell also went. Then only we're muted.
I'm really sorry. Yes, ma'am.
Okay. See, because we have to keep up with the time. We're running short of time.
Yes.
So it was a good piece of work, Ma. But as a person from a medical college, as a faculty of medicine here, what I'm interested in knowing is what is the take-home message? Now, you hurriedly, just because you had to finish, you have presented your data, right? Now, what is the take-home message about carcinoma? That is
thyroid carcinoma and follicular adenoma.
Thyroid carcinoma, and how am I going to differentiate from benign follicular adenoma?
Ma'am, actually, it's
just crisply on any one marker or something.
Those 8 target genes we can work on for further omic works and all that, so that some target can be identified, which will be easy for us without having going for any thyroidectomy and invasive type of surgeries. We can use that as like for FNAB, finding
FNAC is already done.
Yes, ma'am.
It has been done. It has been established.
Yes, ma'am. Yes, ma'am. So by identifying this target, we can make out we can differentiate and we can avoid unwanted thyroidectomy actually.
So do you want us to really see about all the 7 to 8 genes and how is it cost effective for
yes,
the patient?
Ma'am, it will be easy. Ma'am, actually, we can go for further in bioinformatic works itself. Ma'am, we can do omic works. Like we can integrate the proteomics and metabolomic data. And by that, we can screen out this 8 targets into like 1 or 2, and further we can work. So from transcriptomic work, we have screened 8. So later on, we can, by integrating, and this won't cost that much, ma'am, because it is, we are using the softwares only. So that is the application of bioinformatics, actually. We can reduce the cost because already many works have been done in different areas. We have to integrate all those things.
When it comes to application on human samples, when you're doing on a patient,
yes,
okay, so you do a lot of things on the computer. That's you design many things, many models.
Yes, ma'am, we have to validate cell cultures. First start with cell culture and followed by models.
Okay. Okay, ma'am. Thank you.
Thank you, ma'am.
Thank you.
Now, Chandraprabha, abstract number 26, is ready to present a paper. I request Ms. Chandraprabha to present a paper without any delay. Ma'am, Chandraprabha ma'am, your audio is not available.
Chandraprabha ma'am, we are running short of time.
I think, Sangeeta, we can go to the next speaker if somebody else is ready.
Yes, ma'am.
You just please tell me the abstract number. That's enough.
Abstract number 24.
Okay,
Nagi
fine.
Reddy Teja, ma'am, this is for the participant, ma'am. Request Ms. Nagi Reddy Teja Reddy to present her paper, please.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Chandraprabha, ma'am, can you please stop presenting your screen? Only then the next participant will be able to share his screen.
See my screen?
Nagi Teja, you can start presenting.
Ma'am, are you able to see my screen?
No, I'm not able to see your screen.
Yes, ma'am. Wait, ma'am. 2 minutes.
The following participants, please be ready with your presentation. The next one would be Rita and followed by Shalini. Please be ready with your presentation so that you can start off as soon as your names are called. Sir, are you able to share your screen, sir?
I think it's taking time.
Yes, ma'am.
Sangeeta?
Nagi Teja Reddy, sir, please unmute yourself. Please tell us if you're able to share your screen. If not, we can share it for you.
Ma'am, there is no, I'm not able to, ma'am, because PPT is not supporting to that.
We will share, sir. Just give us a moment. So, participants, please let us know if you have any technical issues. We have your presentations, but unless you let us know, we won't be able to help you from our sides. Please be quick to make whatever request you would like to, as it will save a lot of time for all the audience here.
Sorry, ma'am. Sorry for delay.
And that's okay. Stay tuned, audience. The slides will be shared now. So your time starts now, sir.
Thank you, ma'am. I'm Nagi Teja Reddy. I'm doing PG MSc Biotechnology at Reva University. It is a review paper, based on it's on flavonoids and alternative pharmacological compounds against human pathologies. So, ma'am, can you change the slide?
Yes, I'm able to see. Yeah, I can see a slide. You can go ahead.
Ma'am, it is about flavonoids introduction. Flavonoids are the phytochemical and phytochemical phenols which are extracted from the plants like stem and bark or the leaf and the fruit and the nuts. And these are used in most of the pharmaceutical industries for the synthesizing of the drugs. And these are nowadays it is very focusing. Nowadays most of them are focusing on these type of the phenolic groups for the synthesis of the synthetic drugs for the most of the pathologies like Alzheimer's diseases and osteosclerosis, which are related to the brain and the brain diseases, and some of the other like antioxidants and anti-cancer. These are all these in these applicable reasons. These flavonoids are utilized. And ma'am, can we change the slide? Here is a classification of flavonoids. There are nearly six types of types of flavonoids. They are flavonones, flavonols, isoflavones, and calcitones, chalcones, and anthocyanins. These are the basic structure of the is three-ring structure. Okay, and it is very most and very common phytochemicals which are nowadays they're extracting for the further uses. Ma'am, can you explain, change the slide? Ma'am, here are the some of the examples, some of the extracted flavonoids from the certain types of plants and plants, like medicinal plants, and some of the daily use of which are commonly known plants like pepper and all the other things, and with from where they extracted and for what purpose it is used. Like you see the luteolin is a flavonoid which is which was extracted from the aloe vera, from the part of the leaf. It is mainly used for the this flavonoid is mainly used for the antiviral and anti-inflammatory purposes. And there's a camphorol which is extracted from the strawberry. This was extracted from the part of the strawberry fruit and as well as the stem of the strawberry, which were mainly extracted for the purpose of the anti-cancer, and this naringin and quercetin is from curry leaf, and these are were extracted from the leaf of for an antioxidant and treatment of diabetes, and and their references are presented there itself. Ma'am, can you change the slide? For where the biological application means, for what purpose these flavonoids are used, means here are some of the plant names given here, and the way how they extracted those flavonoids from those plants in the flavonoids can be extracted from the methanol and ethanol and the ethers and hexane ethers. And in this manner they are extracted. Ma'am, can you change the slide? Here is a method of here is a applications of flavonoids. Thank you, ma'am. Here the flavonoids are major phenolic groups. It is used in the neurogenesis. Ma'am, you changed the slide. Can you please go back? Thank you, ma'am. Thank you, ma'am. Ma'am, flavonoids are mainly useful in the neurodegenerative disorders for treating of the nerve system and the brain treatment, and it is also used in anti-cancer, where it helps in the and it is also used in anti-inflammatory process and antimicrobial, which helps in this antimicrobial. It kills the bacteria, and the flavonoids are known as produced by plants in response to microbial infection. So it's no surprise that have been discovered by the efficient antimicrobial convert in vitro against wide range of bacteria, and anti-inflammatory like asparagine, apagin, luteolin, and quercetin have been shown an anti-inflammatory and
question answer session. We'll start with the question answer session, ma'am.
Okay.
Allergic properties again in the hello.
Dr. Nagi Teja Reddy. See,
Doctor,
you are well aware.
Ma'am, I'm just a PG student.
Okay. Sorry, you're not. Okay, you're still a PG student. Okay, fine, fantastic. One thing is, you are already informed that the presentation is only for 4 minutes, right? Okay, I think you could have highlighted the important points. You have told about the functions, even it is not quantitative. You could have concentrated on the flavonoids. What is the concentration you require? That part could have been more useful to us.
Okay.
That part could be more useful. You have chosen a review. It's a review, right?
Yes, ma'am. It is a review, ma'am. I said in the starting only. It is a review.
Okay, it is a review, right? But
yes,
if you could tell us that this particular concentration of this quercetin or this, if taken, it is going to be antimicrobial or anti-carcinogenic, that would have been more useful. Okay. So next presentation, please make these changes and try to present it in a better fashion. Thank you. Thank you.
The next participant is Rita, abstract number 25.
Ma'am, can you see my slide, ma'am?
Yes.
Abstract number?
25, ma'am.
25. Rita, okay, ma'am. Yes, ma'am.
Okay, ma'am. My topic is a cross-sectional study on the bone status of hypertensive subjects. Hypertension is also known as blood pressure, a condition in which the force of the blood against the artery wall is too high So on the left side, we can see the ranges of the hypertension: pre-hypertension, stage 1 hypertension, stage 2 hypertension, and hypertensive emergency. So the risk factors are faulty food habits, sedentary lifestyle. Etiology of hypertension is an increase in sympathetic nervous system, increase in production of sodium retaining hormones, increase in vasoconstrictor, deficiency of vasodilators, inappropriate or increase in secretion of resulting in the renin production. Hypertension and bone health. The association between high blood pressure and risk of stroke coronary heart is well established, but the association between high blood pressure and bone loss is scarcely known. Aim and objectives. The aim of the present book is to investigate the clinical relationship between hypertension and bone health. Objectives: to investigate the bone health markers such as protein, calcium, phosphorus, magnesium, alkaline phosphatase, acid phosphatase, vitamin D, and parathyroid hormone. To analyze the bone-related parameters of hypertensive subjects with a non-hypertensive healthy individuals. To assess the status of bone in terms of biochemical parameters with respect to the severity of hypertension. So materials and method. So two groups were taken. Patient group 1, patient with recently diagnosed untreated hypertension. Next, group 2 is subjects having normal systolic and diastolic blood pressure serve control. So inclusion criteria. Two groups were taken. 41 samples for hypertensive subjects, 25 samples for non-hypertensive subjects. Exclusion criteria: patients with antihypertension therapy, patients with liver disease, chronic kidney disease, patients with acute illness, infection, heart disease, thyroid disorders, obese, alcoholic, smokers. Methods. These are the methods were carried out for estimating the bone health markers. Result. So X-wise distribution in cases and controls. So female 32%, male for case, female 32%, male 68%. For control, female 40%, male 60%. Mean blood pressure in study, case and control. For case, the mean systolic blood pressure is 168, the mean diastolic blood pressure is 99. For control, the mean systolic blood pressure is 118, the mean diastolic blood pressure is 76. The data of bone profile in study and control group. Acid phosphatase. So, acid phosphatase and albumin level is increased in cases while comparing with control, whereas calcium, alkaline phosphatase, vitamin D, phosphorus, and magnesium level is decreased in cases while comparing with control. Biochemical parameters with respect to severity of hypothesis. The column shows the stages of hypertension, pre-hypertension, stage 1 hypertension, stage 2 hypertension, and hypertensive emergency. So here also the calcium, alkaline phosphatase, vitamin D were decreasing as the severity of hypertension increases, whereas acid phosphatase level is increasing as the severity of hypertension increases. So discussion. Overall findings suggest an elevated level. Overall findings suggest elevated level of serum albumin and acid phosphatase, and lower serum calcium, phosphorus, magnesium, vitamin D, and PTH in hypertensive subjects. Alkaline phosphatase is a marker for bone formation. It decreases in cases, highlights reduced bone formation in hypertensive subjects. Acid phosphatase has been identified as a bone biomarker for osteoclast activity. In a present study, serum levels of acid phosphatase is shown to be significantly increased in cases as compared to control, which indicates that bone reabsorption or bone loss in hypertensive subjects. Vitamin D levels were significantly reduced in cases as compared to control, showing that mineralization of bone is impaired in hypertension. So, between RAS and calcium regulatory hormone. So, aldosterone secretion leads to sodium reabsorption, which due to reabsorption of sodium, the calcium excreted in urine, and the condition is known as hypocalciuria. Low amount of calcium level in serum leads to secretion of PTH. So because of this PTH secretion, the more amount of PTH secretion that withdraws the calcium from the bone. This causes bone resorption or bone loss. Conclusion. From the present study, it is evident that a close relationship exists between hypertension and bone health. In this regard, we hypothesize that high blood pressure may compromise the integrity of bone tissue via dysregulation of bone cell function at the cellular and molecular levels. Further studies needed to investigate potential mechanisms by which bone turnover markers are related to hypertension. From a holistic perspective, it is considerable that
participants, please kindly mute your audio.
Hypertensive subjects benefit from bone health assessment. So these are the reference. Thank you.
Participants, please kindly mute your audio.
So, Rita, am I audible to you, ma?
Yes, ma'am.
Yes. Can you hear me? So, what type of study it is? Is it a prospective or retrospective study? Do you understand my question? Am I audible to you?
Yes, ma'am.
Yeah. What type of study is it? Is it a prospective study or a retrospective study?
It's a clinical relationship between a hypertension.
Whatever clinical, let it be clinical. It can be prospective.
Yes, ma'am.
Okay, so have you done all these parameters? Have you done it, ma?
Yes, ma'am.
Have you analyzed vitamin D?
Yes, ma'am.
Okay, what is the method that you are using to estimate vitamin D? And have you done with all the samples? Can you show me the vitamin D?
Yes, ma'am. This one, or you want to show the range, ma'am?
Yes.
Vitamin D, ma'am.
So vitamin D is reduced. Just have the slide itself.
Okay.
Vitamin D is reduced. Okay, and your alkaline phosphatase is also reduced.
Yes, ma'am. Calcium, alkaline phosphatase, vitamin D reduced, and acid phosphatase and albumin level is increased, ma'am.
Don't rush up. See, it is your work. Okay. So you just ran through the slides. So basically, what you should have
Mute your
done.
audio. Balaji, please mute your audio.
Can you hear me, ma? Am I audible? Okay, Rita, can you tell me how many samples, what was your sample size for this estimation?
I have taken 41 samples, ma'am. For control, I have taken 25 samples, ma'am.
Okay, so 41 samples.
Yes,
and
ma'am.
you have found your, you have analyzed this vitamin D, it is reduced. But considerable reduction is not there in calcium for this much of reduction on vitamin D. How do you justify? What is the role of vitamin D? What is the role of vitamin D in calcium regulation? It is your work.
It enhances the intestine to absorb the calcium, ma'am, from intestine, ma'am.
Okay.
Absorption of calcium from intestine, ma'am. Role of vitamin D.
Okay. And this acid phosphatase, why have you estimated this acid phosphatase, ma? And it is showing a great spike. Acid phosphatase is showing a bigger spike here. What was your what was the sample that you used? Did you check in the serum or in the plasma? What did you use?
Serum sample, ma'am.
Okay. What type of enzyme is acid phosphatase? Can you tell me?
Acid phosphatase are used to resorb or demineralization of bone, ma'am.
Okay. Forget about the demineralization. Basically, what is this acid phosphatase?
Hello?
Yes, ma. I'm very much, you are audible to me.
Yes,
You have to tell me what type of enzyme is acid phosphatase basically.
Acid phosphatase, it removes phosphate, ma'am, from the molecule.
Even alkaline phosphatase has got that function. Okay, I think we are getting late. And here you have put it as units per liter and international units per liter for alkaline phosphatase. Do you find the difference? How do you express the activity of the enzyme? On what basis?
Sorry, ma'am.
See, your units, your units for alkaline phosphatase, you have expressed it as international units per liter. Acid phosphatase as units per liter. How are you expressing the enzymic activity? And for magnesium, milli-equivalents, there's no U. So be careful when you're presenting, especially it's an international conference. You're supposed to be, you must take more care.
Okay, ma'am. Okay, ma'am.
Okay, and do not rush. Results, you have to explain the results more than the other explanations. You have to justify. Okay, thank you, ma'am. Thank you.
Thank you, ma'am.
The next participant is Shalini, abstract number 28. Shalini, Rita, please stop sharing.
Stop. அதான் ட்ரை பண்ணிட்டு
Shalini?
Yeah, I'll share.
Shalini, you're not audible, ma. Present?
Yes,
your screen is not seen. Yes, you can start presenting. Your screen is not seen. Presentation slide is not seen.
Ma'am, my screen is visible.
Yeah, it's visible, ma.
Good afternoon, one and all present here. Myself, Shalini, pursuing second MSc Biochemistry at DG Vaishnav College. My research topic is biochemical changes in stored whole blood and observational study in a primary hospital blood bank. Introduction. Blood is indispensable life-saving. However, medical invention to treat several medical disorders such as anemia resulting from infection, blood synthesis disorder, drug-related cytotoxicity, and blood loss in accidents during childbirth or during operation. Allogenic blood products are always stored in vitro for a number of days, usually up to 35 days. Additives such as citrate phosphate, dextroadenine at 2 to 6 degrees Celsius. However, a very few have reported such changes in stored blood with respect to blood bank, and no one has reported about the stored blood changes in blood bank. This promoted our present study aim and objective. The aim of present study was to evaluate the biochemical changes occur in units during storage at blood bank, Stanley Medical College, Chennai, to project impact the changes on transfusion. Objectives: to estimate the concentration of biochemical constituents like blood glucose, total protein, albumin, globulin, urea, creatinine, and bilirubin, and to determine the level of serum enzymes SGOT, SGBT, and ALP, and to measure serum electrolytes, sodium, potassium in stored blood on 0th day, 7th, 14th, 21st, 28th, and 35th day. Materials and method. Study area. This present study was conducted Department of Biochemistry and Department of Pathology, Blood Bank, Government Stanley Medical Hospital, located at Chennai, Broadway, Tamil Nadu, Chennai. Subjects 20 to 58 healthy male donors, blood group with the number of donors: A positive 1, B positive 5, O positive 6, tested negative for HCV, HBsAg, syphilis, HIV 1 and 2, malaria. Donors exclusion criteria: hypertension, diabetes, tuberculosis.
blood collection and storage of blood bank. 350 ml blood was drawn from 12 healthy donors into citrate phosphate dextrose adenine anticoagulant and placed on contention for blood refrigerator at 2 to 6 degrees Celsius. 50 ml of blood sample for each blood bag was taken to study purpose and stored in plain bags under all aseptic precautions. Rest of blood was used for transfusion purpose. The sample analyzed 0 day as control and storage was analyzed 0, 7, 14, 21, 28 and 35th day. These are the biochemical clinical and biochemical analysis parameters with the reference method. The results: biochemical parameters at day 0, 7th, 14th, 21st, 28th, 35th of storage. The blood glucose level is ranges at normal ranges at 100.5 to 105.75 by increasing day by day, and finally 35th day at 300.83. By corresponding urea 03 as 28.50, by day it reduces to 19. And the corresponding creatinine, total protein, albumin, globulin, bilirubin, these are all decreases by day by day. And the serum enzymes ALP got decreases by day 35th, and electrolytes, sodium and potassium, sodium level decreases and the potassium level increases. This bar represents the increased level of sodium, decreased level of sodium, increased level of potassium, and decreased level of alkaline phosphatase serum enzyme, and increased level of blood glucose. Discussion. During storage, red blood cells lost their viability over a period of time, leading to hemolysis and negative impact on different biochemical analytes. It is not clearly why there is increased lysis in such units. However, studies suggest reduction in ATP 2,3 diphosphoglycerate and increases in lactate with subsequent fall in pH, with the resulting cell membrane rigidity as the culprits. These biochemical changes renders the cell membrane to rigid and predispose the cells to lyse. Under normal condition in the body's circulation, these do not occur in optimum temperature, pH, nutrient concentration, and waste product removal are well maintained. In this present study, glucose level initially showed an increase from day 0 to 7 of storage, which can due to presence of dextrose in CPDA blood bags. From the day 7th blood storage and beyond till day 35, there was decrease in glucose level, which may due was not significant in the blood study. Total protein, albumin, and globulin in a stored blood was found to decrease concentration when compared to pre-storage. Prolonged storage has been reported to affect the glycolytic pathway, rendering cells susceptible.
You're not audible, Shalini.
Significant changes with AST, SGOT levels, which can because of hemolysis in observed in other studies. RBC contain 20-fold as high concentration as AST as plasma. So even mild hemolysis produced significant alteration in AST. We found decrease in AST value from 0 day to 35th day. It was found to consistent with ALT concentration.
Ma'am, we'll go to question answers, ma'am.
Okay, ma. What is the problem? She has exceeded the time, is it?
Sorry, potassium ion.
Is it the audio problem or she has exceeded the time, Sangeeta?
Audio problem is there, ma'am, and time is also up, ma'am.
Okay. So I'll just ask
And
a hurried question.
Conclusions,
Shalini?
Yes, ma'am. Yes, ma'am.
Okay, ma. So you've been hurrying through. Just tell me that how do you? I first appreciate being a PG student. You have done you have made a great attempt. Very good. But just tell me that how this glucose level is increasing. How do you justify? You have showed that as the days go up, in the 7th day and the 10th day, the glucose level is increasing. How will it increase? Even if dextrose is present, how will it increase? We are not going to add any extra dextrose every time.
Yes, ma'am.
Did you get my point?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Why? How do you say that there is
dextrose is present in and that anticoagulant
okay?
That increases the
Fine.
glucose level.
Sorry to interrupt you. Like even if you're going to add dextrose, okay?
Yes, ma'am.
Now you're going to add it on that day, first collection day, you're going to add.
Yes, ma'am. Yes, ma'am.
Every time you're not going to add on the 7th day and the 10th day, you're not going to add dextrose.
Yes, ma'am.
How is this glucose level increasing? There is no possibility because there will be more of glycolysis taking place, decrease in glucose level will happen. Because oxidation of glucose will start taking place. As per your hemolysis is taking place, all that is happening. So I am not very confident about your results, ma. You have to check up your results.
Okay.
Am I audible to you?
Yes, ma'am. Yes, ma'am.
Okay, because you say the other parameters, so much of deterioration is taking place, so much RBC lysis is all taking place. So there should be greater oxidation. There is no possibility of increase of the glucose. That first point itself is contradictory. Okay, so I think we have exceeded the time. So please keep in mind and just counter check it. Thank you.
Thank you, ma'am. The next participant is Chandra Prabha, abstract number 26. Is Chandra Prabha?
Yes, ma'am. I'm here, ma'am.
You can start presenting.
Yes, ma'am.
26.
Is it audible and visible to you, ma'am?
Yes, ma'am.
Yeah, you are visible.
Yes, ma'am. Thank you. Thank you. Warm greetings to one and all. At the outset, let me express my gratitude to the organizer for giving me a chance for presentation. My topic is on the molecular docking of caffeine and theophylline on the Camellia sinensis buds with human epidermal growth. This Camellia sinensis, it is the tea. Normally, every human being consumes tea next to that of the water as it is a cheapest beverage. And this tea, it is highly appreciated that it contains many of the polyphenols and other components that reduces the risk of developing chronic diseases such as cancer. What is this white tea? Normally from Camellia sinensis, that is from the tea plant, we used to have 3 types of teas. That is the normal tea, green tea and white tea. Green tea, we know it has been processed from leaves. Normal tea, we have certain processes. And this white tea, it is the least processed one. It is just the leaf bud when it sprouts. They are covered with that of the fine white hairs, and that is why it's named as white tea. This white tea, it is highly, because of its unprocessed or without any treatment, it is highly rich in all the antioxidants and especially with that of the polyphenols. So our objective is to extract the secondary metabolites, isolate the polyphenols, and then subject it to the in silico studies. We collected the Camellia sinensis from the Western Ghats, got it authenticated from the Botanical Survey of India. We extracted 10% of the sample. We used water, hydroethanol, and then the petroleum ether. So from these 3, after observing the preliminary phytochemical screening, we had the promising results in hydroethanol, maybe purely because it is able to extract the bioactive components in the aqueous media as well as in that of the organic solvents. So among these three, we found hydroethanol to be highly suitable. Okay. After that, we started isolating the polyphenol using the chromatographic techniques, subjected it to FTIR, and we were able to find a broad band at this particular range. This is mostly due to the stretching vibration of the hydroxyl group. That is due to the presence of more hydroxyl group. We got a broad band at this particular region. We also subjected it to GCMS. We had 21 components. We isolated 21 components. Among that, caffeine had a strongest energy. Caffeine and theophylline had a strongest energy. So we started, or we thought of docking it against the human epidermal growth factor. We selected this human epidermal growth factor because it plays an important role in cell growth and differentiation. So we selected this human epidermal growth factor. We retrieved it from the PDB database, and we started docking it. Okay. The dock was used, docking performance was done by using the auto dock. We started docking it, and we were able to observe that the caffeine and theobromine had a strong binding interactions at the region of arginine, leucine, and glutamine. So this is the results of ours. We had a strong, greater energy for the caffeine and theobromine, 5.8 and 5.1. So the promising effects that is due to the presence of this high caffeine and theophylline. Might be these two factors among the secondary metabolites are highly responsible for their antioxidant phenomena. Concluding notes, again, greater the binding affinity, greater will be the affinity of the drug. So we have a promising effects that this Camellia sinensis, especially the white tea, the unprocessed one, might be having the therapeutic effect, and further studies can be done. This is an in silico. This study can be extended to the wet lab analysis also for the further promising results. Thank you, ma'am.
So, am I audible to you?
Yes, ma'am. Yes,
ma'am. Chandraprabha, it was a neat presentation. Very good presentation. You have done as the methodology was also good. Now we have been prone to this green tea, which we hear it as an antioxidant, right? Yes, now you were telling about this white tea, which is not observed so far, right?
Yes, ma'am.
So I think a research into this would be more promising. Now, could you tell in simple words to the people, to the audience, that what you mean by molecular docking and what you have found in caffeine and theobromine?
Molecular docking, that is using the standard ligand protein, we were able to see the binding affinity between our protein and also the receptor, ma'am. So if we have a greater affinity, then it indicates a promising study for the greater affinity towards the cell line or towards the tumor cells.
So is it anti-carcinogenic also?
Yes, ma'am. It is anti-carcinogenic. We have studies regarding that also. For green tea, we have the anti-carcinogenic property also.
Okay, ma'am. Okay, thank you.
Thank you, ma'am. Thank you, ma'am.
Thank you.
The last paper presentation is by Dr. Sandhya Tambikar, abstract number 21.
Yes, ma'am. Can I share my screen, ma'am?
Yes, ma'am. Chandraprabha, ma'am, kindly please stop sharing.
What is your abstract number, ma?
21.
21, ma'am.
21.
Ma'am, can you able to see my screen?
Yes, I'm able to see the screen.
Okay. Myself, Dr. Sandhya Tambekar Vanzari. I am the Assistant Professor in Microbiology, Dr. Science College, Gondia, Maharashtra. Here I am presenting a paper on the bacteriological evaluation of packaged bottled water and its public health significance. So as we know, water is the utmost important requirement of life and plays vital role in social equity, environmental stability, and cultural diversity. So consumption of bottled water is rapidly increasing in developing countries, especially middle and high income earners, as it is generally pursuing a pure, clean and good quality of water. This bottled water is generally perceived by consumer as being the better quality than the tap water. All the major international and national brands water bottles are available in Indian market, right from the malls to railway station, bus station, general stores and the panwala shop. It is therefore necessary that everyone has the access to safe, affordable, safely quantity of the water for drinking and other personal use. Therefore, the present study ends with the fact that awareness about the bacteriological contamination present in the packaged drinking water, comparative analysis, locally produced packaged drinking water brands, and assessment of bacteriological quality of packaged drinking water samples sold in the Gondia district of Maharashtra, India. So here the international and national brands such as Aquafina, Bailey, Barista, Bio, Bisleri, Drink, Pure, Fresh, Cleanly, and Oxyrich found positive for the presence of pathogenic bacteria, while the brands including local brands such as the Bisleri, Rockstar, Brista, Jalpa, Patanjali were considered safe for the consumption. So here is the material method. Here the total 130 bottled water samples, intact seals, 1 liter capacity of different brands. Samples were collected from the Gondia city, and bottles were washed externally with the sterile distilled water and thoroughly cleaned by the surviving with the cottons with 70% alcohol. 1 ml of the water sample was withdrawn from the bottle and with the sterile pipette and pour it aseptically in the test tube containing 5 ml of McConkey broth with inverted Villerans tube, and they are kept incubation for the 37 degrees centigrade for the 48 hours. After incubation, tubes were observed for the development of yellow color, that is acid and gas formation. Durance tube show as well as the turbidity. The loopful culture from the positive tube was inoculated on the CLED medium, where the loopful culture for the negative showed turbidity inoculated in the cetrimide agar plate. After incubation of this characteristic colony in Newton broth, the broth culture was processed for the morphological culture and biochemical test according to Burgess manual. Then after incubation, 37 characteristic colonies were selected, and this morphology of microorganisms was observed by performing gram staining motility. Biochemical characteristics of the isolated microorganisms were observed by performing in-brick sugar test, triple sugar ion test, catalase, urease, oxidase, and nitrous reduction test. These culture characteristics of microorganisms were observed on the colonies formed by CLED medium and the cetrimide agar medium, which is described by the high medium. Then out of 130 samples of the collected from the different shops of the Gondia city, around 52 samples, that is 40% samples were found to be contaminated with the different pathogen bacteria, whereas 78% sample, that is 68% sample did not show any presence of the bacteria. Here is the graph which shows the more quantity, all the brands containing 10 samples of that particular bottled water. So it shows the more safe water is the Jalpa water, then the Bista water, and Drink Pure water. Most contaminated water shown is the fresh water, then followed with the oxyrich bottles. This graph shows the total contamination and non-contamination of the bottled water. So in the present study, specific Pseudomonas bacteria, then the Escherichia bacteria and the S. aureus bacteria was found. That is particularly pathogenic bacteria which causes different diseases in the human being. So the supply of the safe drinking water for community as well is major concern, but it is well known that the microorganisms multiply in the pipelines of the water distribution system, but it's still subject to research that why it is growing in the packaged drinking water. It was concluded that this bottled water was not fit for the human consumption and are hazardous to health, and strict and routine monitoring of packaged drinking water is required as similar that of the tap water. So it is similar. It is not confirmed that bottled water is safe, but it is same as that as of the tap water which are used by the municipality. So the most stringent standardization of bottled water is required, and special attention to qualify, identity, and licensing for the concerned authority is recommended for the safeguard of the human health. So it is recommended that while in traveling, carry own bottled water and do not entirely depend on packaged drinking water available in the market. The local government authorities must check the quality and packaged drinking water available in the local market and inspect manufacture activity regularly. Industry should assess the quality of bottled water at different stages at the production and post-production to ensure the quality of the bottled water, and follow the SOP, standard operating protocol, that for the water packaging, and to improve the system of processing bottling water to eliminate the microbial contamination. So here are the references. Thank you.
So thank you, Dr. Sandhya Tambika. I think your work has awakened us not to use the packaged bottled water. Yes, ma'am. It seems to be a threat to use bottled water. But madam, there are so many companies, and before it is released into the market, like you have targeted Aquafina and Bisleri, and I think you can show that slide also, madam. Can you please show that slide where you have compared different types of bottled waters? Can you please go to that slide?
Yes, ma'am. Yes, ma'am.
Not this, madam. I want the results. Yeah. Could you here tell me exactly, like Aquafina, the red part is what you want to say there? It is the totally packed bottle.
Total pack bottle which are undergo studies for 10 samples bottles for each brand, ma'am.
Okay.
Yeah.
But madam, how do you justify this? What is your sample size?
So, ma'am,
before you
1
yes,
liter
ma'am.
each bottle. 1 liter each bottle, ma'am.
No. I'm asking about the sampling. How many samples you have taken and tested? Or
yes,
is it only one bottle or several bottles? How many bottles?
So 1 ml in 5 ml of Myconki broth with Durance too.
No, madam, no, you have not understood my question. See, you can take aliquots of water from the same bottle.
Yes.
Have you used different bottles? How many bottles have you taken like that? Samples from how many bottles?
According to brands, ma'am.
Did you get my question, ma'am?
Yeah, ma'am. I get your
See,
question.
taking aliquots, I can take 5 microliters or 10 microliters or 50 microliters several times from the same bottle. But that is not the problem. I have to take aliquots from different samples, different bottles. How many of those have you done? And how do you justify it? Have you got any concrete data for that? Because that is important. Okay. See, because these are, like you have told, Bailey, Bisleri, Aquafina, these are all marketed, and I do think that they will be taking the necessary precautions. Otherwise, at least minimum standards should be maintained. Otherwise, it cannot be marketed so easily. So, have you, to justify, have you taken, what is your sample size? How many samples have you tested?
130 samples, ma'am.
For each thing, like Aquafina 130, on what was the country?
Aquafina, there is 10 samples, ma'am.
10 samples you can't, madam. It can be and different localities, different places. What is your source of water?
Ma'am, as we are lagging time, can you move on to the next person?
Okay. Thank you, Dr. Sandhya. I think you require some more amount of work to be done than coming to this conclusion. Thank you.
This marks the end of the paper presentation. Now we'll move on with the poster presentation, after which it is followed by the validity session. Now I request Smriti Bajpai, abstract number 34, to present her paper.
Yeah, good afternoon, ma'am. Ma'am, please grant me permission for the screen sharing. Yeah.
Ma'am, please start, ma'am. Your time starts now. Unmute yourself, ma'am.
Ma'am, your audio is not available. Smriti, kindly unmute.
Is it okay, ma'am?
Yes, ma'am.
Okay. Yeah, good afternoon, everyone. And thank you so much for giving me this opportunity to present my work. So I have worked on on a small study. It was a small study group. Actually, it is a prospective study. And my work was, it was a survey data of the symptoms following the COVID-19 vaccination. So let me start the topic, like the severe acute respiratory syndrome, SARS-CoV vaccine. This disease has emerged in China in late December 2019, but it has spread like a pandemic. So what has happened when it has emerged? So the vaccine accessibility, the factor by which the vaccine has been formed, vaccine has been manufactured, it was very, it was not supporting, like earlier it was taking 10 years to be manufactured. But due to the very early responses, time, very little time it has taken, so much hesitancy was there in this acceptability of the vaccine. And this was the main work in my survey. Like there are three factors which are going to determine, like confidence, convenience, and complacency. So complacency, confidence, and this convenience, these were linked to the vaccine hesitancy. So in this work, I have just, in this of my work, I have done one cross-sectional study on the basis of a survey in which I have provided the Google form in a study group of around 512 people, and in which I have given one format, and this was a randomized survey among the personals who received the COVID-19 vaccine. And all these personals, they were adult, they were more than 18 years of the age. And these were the college students, faculty members, and some of the aged person. Like I have taken the data from starting from 20 years to 80 years. So these were the groups, and the statistical analysis was also done for these. Okay. So now I'm going to show the result which I have got. The sample size was of around 511 people I have taken into my study. And this was the incidence and the severity of the post-vaccination symptoms with the age. So this is the graph in which we can see the chances of having symptoms that will decreases with the advancing age. So frequency of the symptoms was 75% in the third decade of the life, then 80% in the fourth decade, 73% in the fifth decade, and 34% in the eighth decade. And among those who reported the symptoms, 44.1% were the men, 50% were the women, and they were noticed the symptoms within the 12 hours. Now, if you see the severity of the post-vaccination symptoms, like fever was very much affected. Fever was the main symptom in this. So what has happened, like severity means the fever rate grade, we will see. It was from 99.5 to 102.4. So most of the range that came between that was 65% of age 21 to 30 years, and it was around 65%. And the fever grade was very low during this. This study we have observed. Yeah. Now next, next slide, I will be showing like the assessment of the
Ma'am, sorry for the interruption, ma'am, but the poster presenters were supposed to give us only one slide, ma'am. Only one slide.
Ma'am, actually, I know, ma'am, but for I don't know, I should speak it here. Actually, I gave for poster, ma'am, for antimicrobial resistance, ma'am.
Yeah, we received only one slide from you, but here apparently you're using multiple slides.
Okay, so should I continue, or ma'am, what should I do now?
You can continue and finish it, but I just want to bring it to the notice of our chairperson that, ma'am, for poster presentation, they were asked to give us only one slide, and they have submitted only one slide, ma'am. This is for your
Okay.
So, So for the assessment of the hesitancy, like the hesitancy because of many rumors were there for the vaccination. So in this, what has happened when we have studied like from where they have got the suggestion for the vaccination, what were the places of the vaccination, all these records also we have taken. Like most of the people, 64% they have got there, it was the self-motivation. Then 20% was from the family, and others were the like health professional, from the media, and from the seniors. Like the place of vaccination was also one of the feature which we have taken into consideration. Like 25% were taken the vaccination from the primary clinic, and 24% have taken from the primary health clinic. Now, these are the this is the chart that is showing the sources of awareness, yes, that we have seen earlier. And this is the distribution of the type of vaccines. Majority, more than 80% of the vaccine was Covishield, and 19% was Covaxin, and only 6% were the other. Now, last and the most important factor is the post-vaccination symptoms. So we have seen that the 75%, like 74% of the respondent, they have got at least one post-vaccination symptom, in which the tiredness, myalgia, fever, headache, chills, local pain, joint pain, nausea, all these were the symptoms. So in the study group, which we have taken like 512, 13, so in this, we have seen that this is the range. Majority of the people, more than 42%, they have got the fever. And then it was followed by these other symptoms. Okay. So all other symptoms, these are the main symptoms. All other symptoms were the less than 1%. Now it has come one more thing, like nowadays we are seeing like it is a breakthrough infection. Breakthrough infection means the infection which the COVID infection, again, people are getting after getting their second dose of vaccination also. So that study also I could have done, but it was very small study group. So not much was done. I will do it in the next days. So the people.
Dr. Smriti, I'm sorry to interrupt you. I think you have exceeded the time, madam. It's more like a lecture rather than even what I can say, paper presentation.
Okay, ma'am. So I'll just finish.
It's like a discussion.
I'll just finish it here, ma'am. So
yes, ma'am, you can just finish it there, ma'am. If there are any question answers, you can go directly for that 1 minute time for that.
Yes, ma'am. So the assessment which we have done for the breakthrough infection, so the person who have got both the doses,
ma'am, Vijaya ma'am, you can shoot your questions, ma'am.
Yeah.
Yes, madam. So finally, one thing is the population study. It's a population. It should be a cohort study.
Yes,
right. And the sample population is very less, madam.
Ma'am, yes, ma'am.
513 for this, you cannot come to a conclusion with this sample size.
Ma'am, it was just for the awareness and just to determine the side effect.
So finally, what you want to convey is vaccination is good. Yes, post-vaccination, the chances of getting COVID is lesser. Right?
Yeah, and that hesitancy should be ruled out. Yes, ma'am.
That is the main nutshell. You want to say that
Yes.
vaccination is better.
Yes, safe. Yes.
So you could have come to that point, ma'am, earlier itself, in the one slide itself.
Yeah, ma'am.
And that way it's a demographic study. Sorry, the sample size is also small. We can't take it. Thank you.
Thank you, ma'am. The next participant is Jagadish, abstract number 30.
Abstract number?
30, ma'am.
Okay, ma'am.
Jagadish?
Yeah, it's audible.
Yes, sir.
Good afternoon to one and all present here. Thank you for this opportunity. I am glad to present my research paper before you. I am a research work.
You're not audible, sir.
Wait, ma'am. Sorry, ma'am. Sorry. Yes, ma'am. Thank you for this opportunity. I'm glad to present my research paper. The research work as I'm going to present, entitled as the phytochemical screening, the synthesis of silver nanoparticle using the chromalena odorata as the leaf extract. I'm about to present just a part of a research in which I have worked as the phytochemical screening and is the characterization and antimicrobial activity, which would be our main focus for today, as well as the work has been tested and the cell lines and animal studies and drug production. Going to forward, after the green synthesis of silver nanoparticle using chromalena odorata was done, the phytochemical testing for following components like carbohydrate, terpenoids, resins, saponins, tannins, alkaloid was performed. The characterization of the nanoparticle was also done using the zeta sizer, the zeta potential, UV visible spectroscopy, Fourier transfer infrared spectroscopy, X-ray diffraction, scanning electron microscope, and atomic force microscope. The qualitatively analysis showed the presence of various phytochemical in the plant extract. Going towards the plant and materials, the sample preparation, the sample was collected from the Kodaikanal Mount. The sample was dried and powdered and it filtered. The leaf extract was prepared in some ratio. The extract was kept overnight incubation followed by the filtration. The same procedure was repeated 2 to 3 days. After 2 to 3 days, the extract was poured into the Petri plate and kept inside hot air oven for 45 minutes until ethanol is evaporated. The powder extract was scrapped and stored for the further studies. This materials methods, I'm just showing the pictorial view of the first image is plant name, the second after the ethanol extract, then after the ethanol extract, I'm pouring into the supernatant into the hot plate. This biosynthesis, these are the chemicals. This plant name is Chromalena odorata. I'm using the leaf. The English name is Christmas bush. The Tamil name is Anju Nirambillalai. Going towards the phytochemicals, analysis of the testing, various components were tested like tannin, saponin, flavonoids, alkaloid, glycoside, deoxy sugar, cardioglycols, steroids, terpenoids, phenols, phytosterol, free hydroxyanthraquinones, and anthraquinones. This using the standard protocol, this protocol used for the heartburn. Concluding our research study through the qualitatively analysis of the leaf extract, the presence of the following phytocomponent was observed, which are the tannins, saponin, alkaloid, cardioglycols, triterpenoids, and phenols. For the synthesis, the study on the plant can provide the detailed information about these therapeutic properties and can be used on the drug. I am obligated that I was able to share my research here. I would like to conclude thanking you, Dwarakadas, Govardhanadas, Vaishnav College, and the Department of Biochemistry. I would also like to thank Organizing Secretary, Dr. P.T. Srinivasan, sir, Mrs. Vaideki ma'am, Dr. Sangeeta Satyanarayanan, Dr. Kavita ma'am, Saravanan sir, Nagalakshmi ma'am, Uma ma'am, and Maria Karelin, Dr. Sriram sir. Thanks a lot to everyone.
Thank you, thank you, Mr. Jagdish. It was a neat presentation of the poster. What is your concluding remark? What carries you when compared to others? What is so specific that you want to convey through your...
Yes, yes. My home take, like, this is like just a preliminary work. If I'm telling to, if going to the drug production, if anything means, I'm going further like animal studies and cell lines, everything. So before I'm testing the phytochemical constituents in the preliminary work. In future, like drug production, if anything is required now, I'm going to forward. So the phytochemical and antimicrobial, other basic components like analysis are required. That's what this is like I'm told to everyone.
Okay, what attracted us towards your poster was that you are telling that you are going to analyze green synthesized eco-friendly nanoparticles. So you could have highlighted that. That is what I expected from you.
Yes,
because
this already nanoparticle is done, but here I'm just the phytochemical constituents only showing. It's already phytochemical, like a green synthesis is still one nanoparticle is done. The images I'm already shared. The first image indicates the silver nitrate solution. After the second
okay, sir. Okay,
yes,
sir.
Everything is done. I'm just sharing the phytochemical. The characterization is also done from the following components.
Okay.
Just I'm sharing only the phytochemical.
Okay. I think then the title should have not misguided us, right?
Yes.
The title should have been according to that. Anyway, it's a good piece of work. I appreciate. But with the title, we were carried over. You have done the work, but that is not the work here.
Okay, ma'am.
Thank you. Thank you. It's a good job. Thank you.
Thank you, ma'am. Thank you.
The next participant is Dr. T.S. Subhashini, abstract number 29. Dr. Subhashini.
Can you able to view my slide?
Yes, ma'am, you're audible.
Good afternoon, everyone. I'm just going to give an outline about the usage of artificial intelligence in the field of health. Of course, everyone will be thinking of artificial intelligence means it's simply like a robot coming and talking to us like that. But apart from that, artificial intelligence plays a major role in the healthcare field. For example, in the case of patient care and all, particularly in the case of this COVID situation, where even the near and dear ones also can't go and take care of the patients. In that case, with the help of this artificial intelligence, with the help of these robotic mechanisms, played an important role in carrying the patients in the form of nurses and certain vehicles. With the help of AI, they will carry the medicines and other equipments that are required for the patient. And one more important thing in the case of pharmaceutical industry is currently, in 2021 April, in the case of Germany, and biotech lab, they have used this artificial intelligence for targeted drug delivery. So they have discovered a new drug for cancer, which is much more target specific. So with the help of this artificial intelligence. Apart from that, in the case of diagnostic tools also, if when compared to a pathologist, with the help of this artificial intelligence, that is with the help of this deep learning process and algorithm and all, digital pathology plays an important role. So instead of a pathology, this computer, it can diagnose cancer or any type of cancer in a better way. For example, if a human being is going to see a report, there are certain areas where the person may miss out certain tumors, but this artificial intelligent equipped computers, they'll tend to identify the tumor. Specifically in the case of lung cancer and all, it can be identified some 2-3 years earlier itself with the help of this artificial intelligence. And coming to the impact in the healthcare, as I said, if you're going to keep a clinic or any dental or medical, whatever it may be, so we have to first have a room and we have to have a a lot of administrative staff and all. But in the case of this artificial intelligence, as we know very well, now we started using so many app like Practo, Doctor Calls, all those apps now. So they are nothing, just a simple example for this artificial intelligence. So this artificial intelligence based technique, no, it can, a single instrument can do a work that can be done by 50 to 60 people. So this administrative part itself may even become much more easier. And even coming for this clinical trials and all also, no, instead of maintaining larger and larger number of files in so many folders, all those things, no, that are easily replaced nowadays with the help of this artificial intelligence based coding techniques. So it will be very much useful for preserving all the data in a greater way. Finally, coming to the conclusion part, the main disadvantage of this artificial intelligence is the cost. Now, but once now, if everyone starts doing a lot of research in the field of this artificial intelligence, of course, we can be able to manufacture the instruments in a much cheaper price. And but coming to the main advantage, no, as I said, in the case of cancer, this artificial intelligence based diagnosis, no, if you are going to diagnose a patient some 3-4 years earlier than he gets the actual pathological state, means we can save the money which the patient is going to incur during all these 3-4 years, and we can even increase the lifespan of so many people. So that's also finally coming to the conclusion. So we have to have a good awareness about artificial intelligence. It's not that it's only related to software or any engineer like that. So artificial intelligence became a part and parcel of our life. Best example is our Arogya Setu app that we are going, that plays an important role in the management of COVID. So thanks a lot for giving me this wonderful opportunity. Thank you so much.
Okay. Thank you, Dr. Subhashini. You have created, it's now this artificial intelligence has mainly played a very important role. Now people are using this artificial intelligence for many things. So it is coming into play. But the only thing is, this is as a review article, isn't it?
Yes, ma'am.
So we don't have a data. So based on this artificial intelligence, your presentation, your poster, the presentation of the poster is fine. The audiovisual aids, what you have used is fine. Your conclusions, everything is fine. But I think it would have been better if we had some data.
Okay, ma'am. Next time I'll do it, ma'am.
Yes, ma'am. Thank you.
Thank you, ma'am.
And the next participant is Sakshi Prasad, abstract number 31. Sakshi Prasad? Yes. Sir, you're not audible.
Just excuse me for a minute.
Yes, ma'am. The participants, stay tuned. Ma'am will be back soon.
Yes, you can carry on, Mr. Sakshit Prasad.
Sir, can you please share your screen?
Sakshit Prasad.
So we'll move on to the next participant, Farhat Mateen, abstract number 33. Farhat Mateen, are you there?
Yes, ma'am, I'm available.
Yes, ma'am. After this, you'll present. Now Sakshit Prasad has come.
Yeah, okay, fine.
Sir, please change your mode. Change it to landscape mode. It is in portrait. Participants, please mute your mic and also videos. Kindly mute your mic. Nitish Kumar. Sakshit Prasad, can you hear me? Sir. Mr. Sakshit Prasad, are you there? Sir, okay, fine. Stop sharing and we'll call you next. Sir. Kindly unmute yourself. Farhat Mateen, ma'am, you can. Abstract
Yes,
number 33, Farhat Mateen.
Yes, Mr. Farhat Mateen.
Yeah, yes, ma'am. Can you able to see my poster, ma'am?
Yeah, I can see your poster.
Yeah, thank you. Very warm good afternoon to everyone. Myself, Farhat Mateen, research scholar from Madras Christian College, and my topic is antibacterial activity of essential oils based on nanoemulsion against human pathogens. So this one is my abstract. I'm going to simplify my abstract that I have prepared oil in water nanoemulsion of peppermint, thyme, and citronella essential oil by using ultrasonication method, and I have tested the antibacterial activity against the different human pathogens, and we have noticed the good antibacterial. The nanoemulsion has exhibit a good antibacterial activity. So, introduction. Essential oils are volatile substances. They are naturally present in the herbal plants. There is a global demand in the market for the production of essential oil due to their unique properties such as fragrance, flavor, and also consist of various biological activities. During the 13th century, the essential oils are used by chemists for their pharmacological effects and also for its antibacterial, antiviral, antifungal, and antioxidant properties. But when we use this essential oil directly for any application, there are also a few drawbacks like less water solubility, low stability, and strong flavor. So I have used the technology, which is called as nanotechnology, have paved a way to overcome these factors and help us to enhance the antibacterial activity. Therefore, in our study, the antibacterial activity of the essential oils such as mentha, Piperetia thymus vulgaris, and Cymbopogon nardus of nanoemulsion were formulated as nanoemulsion and were tested against the human pathogens. So the materials which I have used over here is the essential oil of peppermint, thyme, citronella, and surfactant twin 80, and the solvent acetone and distilled water we used. The microorganism, the bacterial strains such as gram-positive bacteria, Staphylococcus aureus, and Bacillus subtilis, and gram-negative bacteria, Escherichia coli, and Enterobacter soli were pre-cultured in Muller-Hinton probe overnight in a rotatory shaker at 37 degrees Celsius. Afterward, each strain was adjusted at a concentration of 10 to the power 6 cells per ml using a 0.5 McFarland standard. So the methodology I have used for the preparation of nanoemulsion, as I have mentioned earlier, oil in water method was used for evaluating the formulation of nanoemulsion by mixing the oil, surfactant, solvent, and distilled water at the ratio of 10%, 24%, 6%, and 60% concentrations. The mixture was first exposed to magnetic stereo process for the formation of coarse emulsion and then subjected to ultrasonication for the formation of nanoemulsion. So the next is the characterization of the nanoemulsion. The formulated nanoemulsion was expressed through different thermodynamic studies, such as centrifugation, heating cooling cycle, and freeze-thaw cycle to check the stability state. After stability state, the particle size of the formulated nanoemulsion was analyzed using the DLS method. Next is the antibacterial assay. Bacteria were pre-cultured in the Miller-Hintonga broth. The agar plates were prepared, and then by using the sterile swabs, the agar surface is inoculated by microbial inoculum. I have used this 4 different bacteria in a separate petri dishes. By using the sterile gel puncher, the wells were made, and into the wells, the 100 ml of 3 different nanoemulsions such as peppermint, thyme, and citronella oil samples were added, and 6% acetone was used for the control treatment. Finally, the plates were incubated at 37 degrees Celsius for 24 hours, and after incubation, the plates were observed for the zone of inhibition. The zone of inhibition size was measured by using the scale, and the values were interrupted. So in the results and discussion, after the thermodynamic study, I have noticed no phase separation. The no phase separation indicates the stability of the nanoemulsion. And then I have to for the particle size analysis. So we can see the peppermint particle size is 10.84, thyme particle size is 12.81 nanometer, and the citronella particle size 27. In the bacteria assay, you can, so I have already mentioned, the zone of inhibition exhibits by the 3 different nanoemulsion, and they're also already Sarania et al. 2012 has formulated eucalyptus oil nanoemulsion, the particle size of 20 nanometer, and they have tested again the Proteus mirabilis, and which also exhibits a bactericidal activity. So this one is a zone of inhibition. In this tabular column, you can see the peppermint nanoemulsion has exhibited the more zone of inhibition, and this one is the graphical representation. So conclusion, this study proves the formulated nanoemulsion peppermint, thyme, and citronella has the antibacterial activity against the tested human pathogens, but peppermint oil nanoemulsion has shown that it is more effective against the pathogen when compared to the other 2 nanoemulsion. So this difference may also be due to the particle size of the formulated nanoemulsion, and these are my references. Thank you, ma'am.
Good. Farhat, you have done a good study. It is a neat presentation. Yes, you have tried to make it up. Sorry, you have just exceeded the time, but okay. My question, only one question I want to ask you is why do you think that this peppermint nano emulsion made through peppermint is better when compared to the other citronella and other essential oil?
Ma'am, we have a lot of factors, like lot of differences. But when I have done the GCMS analysis of each samples, I find the sample compositions in the peppermint was more, the GCMS analysis. So this may also differ. Even the particle size also differ. But in my slides, I have highlighted the particle size. So this difference may also be due to the particle size.
Okay, it was good, but you could have put your GCMS analysis graph. That would have been very explanatory, isn't it?
Ma'am, since it is a poster presentation, I can't.
That is what. No, you needn't be. It would have been self-explanatory.
Yeah,
right?
Ma'am.
Instead
yes,
of going word to word and line to line, make it more pictorial.
Yeah,
you're trying to convey what you want. Good, thank you.
Yes, ma'am. Thank you so much.
Yes, ma'am.
The next participant is Sureka, abstract number 32. Ma'am, are you ready?
Yes, yes.
Sureka, ma'am.
Ready. Can Farhat Mateen can stop there.
Can have you can, ma'am.
Is my slide visible, ma'am?
Yes, it is visible.
Myself, Dr. Sureka, working as a lecturer in the Department of Biochemistry, SRM Dental College, Ramapuram. Today, I'm going to present an e-poster on thymoquinone loaded solid lipid nanoparticle elicits
antioxidant effect against 3-nitropropionic acid-induced Huntington's disease. Huntington's disease is a devastating neurodegenerative disease which is caused due to the accumulation of mutant Huntington protein in the brain striatum. The accumulation of mutant protein causes a generation of free radical, and that eventually leads to the degeneration of striatal neurons. The similar mechanism of HT symptom was experimentally produced upon administration of 3-nitropropionic acid, which is a mycotoxin found to induce free radical generation and striatal neurodegeneration. Therefore, the present study was aimed to investigate the protective effect of thymoquinone, which is a bioactive component of Nigella sativa seed, which is loaded into a solid lipid nanoparticle and tested against 3-nitropropionic acid in the regulation of neurotropic factors and antioxidant defense mechanism in the striatum of male Wistar rats. So the experimental animals were divided into 8 groups with 6 animals each. Coming to the result, so upon administration of 3-nitropropionic acid, the level of BDNF and GDNF was found to be reduced when compared to control animal. This was found to be increased upon treatment with nano-TQ 10 and 20 milligram and 80 milligram dosage of thymoquinone suspension, then 40 milligram dosage. Nano-TQ and blank SLN did not show any significant changes. Further, the downstream regulatory protein of BDNF, that is the phosphorylated PI3K and phosphorylated AKT expression, was found to be reduced upon 3-nitropropionic acid treatment, which was compared to be increased upon treatment with nano-TQ 10 and 20 milligram and 80 milligram of thymoquinone than 40 milligram dosage. Nano-TQ and blank SLN did not show any significant changes. Same way, the pro-inflammatory proteins like phosphorylated P38 MAPK and phosphorylated JNK was tested, where the 3 and 5 administration showed increased expression of phosphorylated P38 MAPK and JNK when compared to control animal. The expressions were found to be regulated upon treatment with nano-TQ 10 and 20 milligram and 80 milligram of TQ than 40 milligram dosage. Nano-TQ and blank SLN did not show any significant changes. Further, the antioxidant transcription factor, that is NRF2 and HO1, was found to be downregulated upon 3NP treatment, which was found to be increased upon treatment with nano-TQ 10 and 20 milligram and 80 milligram of TQ than 40 milligram dosage. Nano-TQ and blank SLN did not show any significant changes. So this picture shows the schematic representation of my study, where this is a general procedure, general pathway where BDNF found to phosphorylate the PI3K and this further phosphorylate AKT. The phosphorylated AKT in turn ubiquitinase keep and facilitates the nuclear translocation of NRF2. NRF2 in turn binds to ARE to produce antioxidant genes. This can inhibit the neuronal apoptosis. Further, the 3NP administration found to reduce the level of BDNF. Therefore, the phosphorylated expression of PI3K AKT is downregulated, leading to the sequester of keep and NRF2, leading to the reduced translocation of NRF2 into nucleus. This in turn reduces the antioxidant gene. Further, the reduced antioxidant expression leading to the increased generation of free radical. This increases the pro-inflammatory proteins like NF-kappa B and MAPK or JNK. This can also lead to neuronal apoptosis. Further, administration of nano-TQ found to govern the level of BDNF, thereby the AKT phosphorylation, PI3K phosphorylation will be restored, so which facilitates the NRF2 translocation to the nucleus, that facilitates the transcription of antioxidant gene that can inhibit neuronal apoptosis. Further, the antioxidant genes can reduces the ROS generation. This in turn reduces the pro-inflammatory proteins like NF-kappa B and MAPK and also inhibits the neuronal apoptosis. Therefore, it is concluded that the thymoquinone loaded solid lipid nanoparticle found to elicit the antioxidant defense against 3-nitropropionic acid HT. Thank you for the opportunity. Thank you, ma'am.
Thank you, Dr. Surekha. It is a very neat presentation. And could you tell the audience what is this Huntington's disease?
Huntington's is a neurodegenerative disease. It is caused majorly in the elderly person, where the striatum region in our brain will get degenerated. So the patient will be developing a chorea-like symptoms. Chorea will be like the patient will be showing jerky movements. So that is the major symptom of Huntington's disease. This is similar like Parkinson's disease.
It's more like a Parkinson's disease. It's a neuro.
Where in this disease, Huntington protein will be accumulated in the striatum of the brain, which is due to the mutation in the gene encoding Huntington, where the mutant protein will be having more of polyglutamine repeats.
Right, good. So how did you select this nitropropionic acid?
This is
Was
a
it,
golden, yes, ma'am. This is a golden standard
okay.
model for Huntington's
Okay.
disease, where systemic administration of 3NP can experimentally induce HT directly. So systemic administration is more preferred. So instead of doing surgery to induce Huntington's disease, here 3NP administration systematically through intraperitoneal administration, the animals could be able to develop the symptoms of Huntington's disease.
Okay, thank you very much. It was a very nice presentation. Thank you.
I now request Sakshit Prasad, abstract number 31, to present the screen. Sir, please.
Yes, ma'am.
Yes, sir.
Sir, can
Mr. Sakshit Prasad.
He's done. Sir, we can't hear you. Can you please move to some other places? There is some network issues, it seems.
Am I audible, ma'am?
Sir.
No.
You're not audible, Mr. Sakshit Prasad. There is a breaking of voice. Your poster is visible. Mr. Sakshit Prasad.
Ma'am, I think he's having some network issues, ma'am.
So what do we do? The organizers have to tell me.
Please just let him go, ma'am. Just bad luck.
Okay, fine. Okay. Then I'm done with the evaluation. I'll just WhatsApp to you, Sangeeta.
Yes, ma'am. Yes, ma'am.
Is there anybody else remaining? We are done. The calculations, everything are done. The evaluation is over. So I'll just send the evaluation form to you.
Yes,
now.
ma'am. Yes, ma'am. Yes, ma'am.
Could you engage them for 5 minutes?
Yes,
I'll just finish up.
Please hold on, ma'am. Just hold
Yeah.
on, ma'am. One more.
Yeah. I'll talk to them. I'll talk to the.
Yes.
Okay, just a minute. The
Yeah.
session was
I just want to WhatsApp this results to you. That's all. And I'll talk to you all.
Okay, ma'am. The session was packed with both 7 paper presentations and 6 poster presentations. I hope you all enjoyed it. May I request Dr. Vijaya Srinivasan to give her concluding remarks. Ma'am, please.
Yes. So thank you very much to all the participants. Before I proceed any further, I would like to thank the management, Principal Dr. Santosh Babu, and the head of the Department of Biochemistry, Dr. P.T. Srinivasan. My video is not on. Yeah, video is on.
தெரியுது ma'am. Video தெரியுது.
தெரியுதுங்களா? ஓகேப்பா. So, the head of the Department of Biochemistry, Dr. P.T. Srinivasan, for inviting me to this august occasion. It's definitely a proud privilege to have this opportunity to be part of the International Conference of Infectious Disease in an era of vaccine. We're all well aware that the whole world is under the grip of pandemic COVID-19. A conference which creates awareness of such a problem, not essentially COVID-19, but okay, about any infectious disease is the need of the hour. What we basically required is the concerted efforts of the physicians, social workers, researchers, healthcare workers to defeat this pandemic and any infection for that matter through the awareness amongst people. I would like to quote a beautiful saying by Louisa Mary Alcott. I am not afraid of storms, for I am learning how to sail my ship. So when the hero within, hard times don't create heroes. It is during the hard times when the hero within us is revealed. The post-pandemic environment has unlocked a plenty of innovations in every field. It was a pleasure to see how our young students, especially the MSc final year students, participating and equally competing with the doctorates and other specialists. This is the positivity, the courage in our children that the whole world wants and is waiting for. There was a plethora of speakers with vivid approaches to eradicate the problem of infection with their unique ideas. It was rather very difficult for me to judge the best paper and poster, as each and every presentation was unique, especially to select a best paper in a place where there are diverse fields. Bioinformatics, biotechnology, biomedical science, biochemistry made the assessment all the more difficult. But I greatly appreciate all the participants for their wonderful presentation. We have assessed your presentation. So this is the method of assessment of your presentation. It has been on the basis of content, the originality of the article, novelty, ability to answer the questions, adequacy of knowledge, clarity in presentation, and top priority has been given to the time management. There is no low achiever. Everybody's contribution to research is praiseworthy. I'm sure all your ventures to carry out research would have been a scientific feast of deliberation. I greatly appreciate the untiring efforts taken by Dr. P.T. Srinivasan sir and his wonderful team, which has made this dream of conducting an international conference of this great magnitude a grand success in midst of their ongoing NAC accreditation preparation program. The most awaited moment has at last come. I'm sure all of you will be eagerly waiting to know the results of your paper and poster presentation. So with no further delay, I would request the organizers to kindly reveal the results. Please remember, success is a journey, not a destination. Don't limit your challenges, challenge your limits. If you love what you're doing, you'll definitely be successful. Thanking you. This is Dr. Vijay Srinivasan from Sri Ramachandra Institute of Higher Education and Research signing off. Thanking you.
Thank you,
So
ma'am.
I'll send the results within few minutes time. 2 minutes.
Yes, ma'am. Yes, ma'am. Thank you so much, ma'am. It was a pleasure having you. Though I think there were a number of presentations for this session, and the question answer session was also interesting. Thank you once again, ma'am, for your patient listening, for all the time and all the keen interest that you took in questioning the participants. Our principal, Dr. Santosh Babu, is here with us. I would also request Dr. Vijaya ma'am to stay back for the valedictory session, which is about to begin. So good evening, sir.
Good evening.
Sir, good evening. Yeah.
Good evening.
Thank you, ma'am. As we have come to the close of the conference, the time has come to draw a curtain. A very good evening and a warm welcome everyone to the valedictory session of the International Conference is in an era of vaccines. The last 2 days have helped us gain insights into several topics. Scholars from across the globe have enlightened us for the last 2 days, helping us gain insights into several topics. My heartfelt thanks to all of you. We have Amit as our dynamic principal for this session. I now request Professor S. Vaidehi to brief the gathering about the credentials of our beloved dynamic principal. Ma'am, please.
Good evening, sir. The fragrance of flowers spread only in the direction of the wind, but the goodness of a person spreads in all directions. It's a great honor for me to introduce and welcome our principal, Dr. Santosh Babu, for delivering valedictory address. He is well known for his work in the field of education. Captain Dr. Santosh Babu has around 29 years of postgraduate teaching experience in computer science, which includes 6 years of administrative experience as a head of the department and 2.5 years as registrar, Manonamayam Sundarnar University, Tirunelveli. He has served as NCC officer from 2004 to 2017. Added on to a feather in his cap, Sir has completed major research project funded by UGC worth rupees 8,63,300. He has guided 38 research scholars in computer science. He has more than 100 paper publications in highly reputed peer-reviewed national and international journals. Sir has also served as member in various peer-reviewed journals. Sir is a member in the Board of Studies in several autonomous colleges and has designed the curriculum for undergraduate and postgraduate programs in computer science. Dr. Santosh Babu has inspected more than 50 colleges for starting new courses or continuing affiliation in computer science. Sir has served as a convener and member of Inspection Commission, University of Madras and Bharatiyar University, Coimbatore. Sir is a visiting faculty to many IT companies. Sir has acted as resource person for the UGC sponsored refresher course in computer science in the Chandrasekhara Deemed University, Kanchipuram, Tamil Nadu, as well as in Bharatiyar University, Coimbatore. We look forward to your valedictory address today, sir. Sir, once again, a warm welcome to you. Sir, please.
Very good evening to all. Today is the end of our 2-day international conference on infectious disease, the era of vaccine. The Department of Biochemistry, head of the department and their team, with the support of the external members, they have conducted this international conference. I understand that the people from various countries and various states have participated, like US, Malaysia, Bangkok, and Canada, which is a success for Dwaradas Mohandas Vaishnav College during the 50th year celebration of the department. Always the conferences and seminar is a very backbone for any institution for knowledge sharing among the faculty members and knowledge gaining for the research scholars and the students. Once we used to think that always research is only, the research domain is only meant for universities. But the trend is changing where the research is a universal one. Even the school teacher can do research. So this is the very basic thing where research, even not only school teacher, even the student pursuing +2, the students who are pursuing undergraduate, even the students who are pursuing 6th standard can do research, which is very important for the country. In this situation, the department have taken or correlated two things. One is infectious disease correlated with the vaccine. As a lay person, the people used to tell that in the field of medical, after finding out the vaccine, the pharma company itself will test that particular disease. Undoubtedly, unfortunately, from the lab, it had gone out of the lab and it will be spreads to the public. And if that like that, only most of the infection will come. Even our present COVID-19 problem also, it happened only, I think, because of the researcher. So the research has to be done for the constructive purpose. The research should not be for the destructive purpose. That is most important. Even in the field of computer science, the people used to talk about hacking, ethical hacking, and security, cyber security, all these things. In field, there are a lot of research is going on. As far as life science is concerned, where a lot of unknown diseases, unknown viruses are there, now the people started doing research on finding, labeling, naming, all these things are happening. During this process only, we used to have an accident. No human being, nobody will do research for destructive purpose. When they do constructive research, during the time, some accident will take place. So we used to drive a car for a long distance. Why we are going why we are going by car? You want to reach the place in time. But during the time, the accident will happen. Like that, the accidents are happening in the field of life science. But this conference, I understand that more people have presented a paper on various topics on the life science. Definitely, it will be helpful, or it will be an eye-opener for all the faculty members and also to the students. I do suggest that we, the academic fraternity, have to do research on the respective field for constructive purpose. With these few words, once again, I like to thank all the experts from various countries, various institutions who have joined through our Dwarakadas Gorandas Vaishnav platform to share the knowledge. I like to thank them for accepting and being with us for the past 2 days to have the constructive discussion on various topics. Thank you very much. Thank you. Thank you.
Thank you, sir.
Thank you, sir, for your encouraging words. To the kind attention of the audience, feedback link will be posted in the chat box. It will be available only until 5 p.m. today, 19th October 2021. So kindly fill it by then. Saying thank you is more than good manners. So to express our appreciation and the gratitude, we have with us Dr. Sangeeta Satyanarayan, who will propose the vote of thanks. Ma'am, please.
Okay, so the the much awaited aspect of the international conference, today international conference, we have the jury, who have judged the presentations from the various scholars across the country and across the globe. We have a best paper award, an appreciation award, and so we thank the jury, the judges from various institutions who have taken their time and gone through meticulously all the presentations of the participants who have contributed their research to the two-day international conference. So without wasting much of the time, I straight away go for the announcement of the results. So let me start with the best paper award. The best paper award goes to Prasanna V. Shekhar, research scholar, Department of Plant and Environmental Science, Clemson University, USA, with his paper title In Silico Pipeline for Aptamer Selection for Efficient Detection of the Human Coronavirus Family Spike Proteins. Congratulations, Prasanna V. Shekhar. We really appreciate you for sharing your knowledge and thoughts and your study on the lines of this coronavirus in terms of this your in silico.
I request the best paper awardee.
Sir?
To say, I request the best paper awardee to have a special lecture to our student.
Yes, sir. Sure, sir.
Later. Please have the contact with her and you arrange a lecture for our UG students combining both biotechnology and biochemistry.
Yes,
because
sir.
we have to found a good researchers from the undergraduate level. Thank
yes,
you.
sir. Yes, sir. Sure, sir. We'll do that. Yeah. The next award is the Appreciation Award for participating in the Today International Conference. The Appreciation Award goes to Dr. Vinodini, Assistant Professor, Department of Pharmacology, SRM Dental College, for the work paper title Antibacterial, Antitubercular and Antioxidant Activities of Bioactive Compounds Obtained from Hexane extract of Tuna ciliata leaves. Congratulations, ma'am, for sharing your knowledge and research aspects of your research work on Tuna ciliata leaves. So we'll be getting in touch with you after this conference.
Thank you, sir.
Yeah. So in today's session, we have another Best Paper Award, which goes to Dr. Chandra Prabha of Ramakrishna College of Arts and Science for Women, Coimbatore, for the study on molecular docking of caffeine to theobromine of Camellia sinensis buds with human epidermal growth factor receptor. Congratulations, Dr. Chandra Prabha, for sharing your research aspects and findings of your work title on this caffeine to theobromine of Camellia sinensis buds. Then the next award is the Best Poster Award. That Best Poster Award goes to Sureka Ramachandran, Department of Biochemistry, SRM Dental College, for the work titled Thynoquinone loaded solid lipid nanoparticle elicits antioxidant effect against 1-nitropropionic acid induced Huntington's disease. Thank you, ma'am, and congratulations for getting selected to be the best poster and for sharing your research knowledge and the findings of your work on this Huntington's disease related to this thyroquinone loaded solid nanoparticles. Yeah. So now, congratulations to all the awardees of this Today International Conference. So we will be getting in touch with you for maybe a talk on the work that you have done and presented in our conference. Now I request Dr. Sangeeta Satyanarayana of our department and the organizing secretary of this Today International Conference to propose the vote of thanks. Ma'am.
Thank you, sir. A very good evening to all present here. I'm sure that the 2-day international conference gave all your minds an intellectual treat. But this did not happen overnight. There have been a lot of hands and minds, hearts and souls at work for quite some time. Gratitude makes sense of our past, brings peace for today, and creates a vision for tomorrow. I thank the Almighty, the presiding deity Lord Krishna, in whose hands we remain instruments. We have often heard people say, trust in God's timing, and that's what we did to make this e-conference a reality. Have faith in your abilities, work hard, and there is nothing you cannot accomplish. These are the words often said by our revered secretary, Sri Ashok Kumar Mundraji. As the chief patron of ICIDEV 2021, he gave us full freedom to execute the program and also provided us the Zoom platform to facilitate the same. Thank you, sir. Our sincere gratitude goes out to our principal, Captain Dr. S. Santosh Babu, patron and convener of this conference, for his rock-solid support and encouragement at all times. His mere presence springs us with a lot of energy. Thank you, sir, for always being here whenever we have needed you and being there even when we have not needed you. Thank you once again. An international conference of this scale would not have been possible without the kind consent of our resource persons. Knowledge makes people humble is what we clearly realized in the interactions with them. I thank each and every one of them from the bottom of my heart. The members of the advisory board are equally well read. They have contributed to the technical sessions and have also readily shared abstracts for our conference proceedings. We are very lucky to connect with such a galaxy of scientists across the country and outside. Change is difficult, but often essential to survival. These are the resonating words we have often heard from the head of our department, Dr. P.G. Srinivasan. An e-conference was always his cup of tea, as he thought that connecting to scientists across the world was very important and practically possible only through such online platforms. A good leader is a person who takes a little more than his share of the blame and a little less than his share of the credit. That's what describes him best. Thank you, sir, for everything. If everyone is moving forward together, then success takes care of itself. That's how I could best describe the contributions of my colleague at the department. I would especially like to place on record the untiring efforts of Professor S. Vaidehi and Dr. J. Sriram Prasad as organizing secretaries, Dr. D. Venkatesh for taking care of registration, Professor Maria Carolyn Rebello, the faculty coordinator of Newburgh Crew, for playing the master inaugural session and preparing the students for the rest of the sessions. My thanks are also due to our librarian, Dr. Manigandan, for helping us get the ISBN number, Mr. Prem of the data center for Zoom link, Mr. Kumaran, our electrician, for our power backup. Any program, no matter what its magnitude, will remain incomplete without the right audience. We are very thankful to all the delegates from different institutions for participating in the conference and making it a resounding success. A teacher's purpose is not to create students in his or her image, but to develop students who can create their own image. Every bit of this two-day conference was put together by our enthusiastic students, from preparing the flyer, designing the brochure and banner, making the invitation, shooting out mails to the participants, sending telegram message reminders, editing and printing the e-proceedings, and many countless small little things. I thank the office bearers and the executive committee members of the Newburgh Crew on the whole. At the same time, I acknowledge with appreciation the untiring efforts of a few of them. A big thanks to Duke Thomas, the Vice President of the Newburgh Crew, Netra Shri, the Treasurer of the Crew, Jayalakshmi, Roshni and Vigneshwaran of 2nd BSc Biochemistry, Sanju Vikasini, Jamie, Satyashri of 2nd MSc Biochemistry, Sai Krishna, Yukesh and Harish of 3rd BSc Biochemistry. Thank you, children. We missed this type of interaction over the past 18 months. As we express gratitude, we must never forget that the highest appreciation is not to utter words, but to live by them. As mentors of the future, in particular the scientific community, we the faculty in the Department of Biochemistry, Dwarka Das, Govardhan Das, Vaishnav College, will remain committed to the endeavor of enlightening young minds. Once again, my deepest, heartfelt thanks to one and all. This is Sangeeta Satyanarayan signing off as the organizing secretary of the International Conference on Infectious Diseases in an era of vaccine. Thank you, one and all. Let us all raise for the national anthem.
Yes.
Yeah. जनगणमनाधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उत्सल जलसि तरंगा तब शुभ नामे जाके तब शुभ आशीष मागे दागे तब सय गादा जन गण मंगल नायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you. Thank you, audience. Thank you, Vijay ma'am, for staying till the end.
Thank you,
Principal
Sangeet.
sir. I
Thank
request
you,
the
sir.
participants to please fill up the
Thank you, ma'am.
feedback form.
Yes, thank you, ma'am. Thank you for being with us till the end of the program. I thank all the participants who are with us till the end of this program. It's a great feeling and a great pleasure to have this being organized as a two-day international conference. We look forward to more such type of cooperation in future, and which will encourage us to have more and more programs in future. We would look forward to more such type of collaborations. Thank you, one and all. Let's God
Thank you,
wishes
sir.
on that. Yeah, thank you, ma'am.
It was a great opportunity, sir. Thank you very much. Very good organization. Kudos to your team. Thank you, sir.
Thank you, ma'am. Thank you. Thank you very much.
ஆட்டோமேட்டிக்கா தான் வருதா கொடுக்கலாம் அதான் நானும் கொடுக்குறேன் சரிப்பியா ஆயிடுச்சா போயிடுங்களா ஓகே வரவேண்டும்